59분. Attention please. The conference will begin shortly, so please be seated. 곧 행사가 시작될 예정이오니 착석하여 주시기 바랍니다.
We will soon begin shortly.
Your Excellencies, dear guests, ladies and gentlemen, I'm Tia Lee from the Hungarian Embassy in Seoul and will be your host for today. I'm very happy to welcome you to the V4 Public Diplomacy event, Clean Energy, Flavors and Melodies. This event is organized to celebrate the Hungarian presidency of the Visegrad Group. The first part of the event is a mini conference about the clean energy research in V4 countries and Korea. The second part is a cultural program featuring Visegrad melodies. Since we have some technical issues, please wait for a moment. Now let's begin. First, a welcoming remark will be given by His Excellency Moses Chomo, Ambassador of Hungary to Korea. Please welcome Mr. Ambassador.
Dear Ambassador Min Won-ki, dear Ambassador Slamečka, dear Ambassador Kuderjavi, dear Deputy Head of the Polish Embassy, colleagues here in the Lotte Hotel, and colleagues in online, ladies and gentlemen. Thank you very much for joining us today. I'm 100% sure that we will have a very useful and interesting afternoon. Looking at the program, you can see that it is divided into two parts. First is going to be a mini conference about clean energy and research in the V4 countries and Korea. Then we will have a brilliant cultural program. One of the main purposes of our event is showing to our Korean friends how deep is the cooperation between these Central European countries, Czechia, Slovakia, Poland and Hungary, the countries which are located in the same cultural region and are sharing common values. The cooperation of our countries started in the 14th century. In the year 3035, the rulers of Hungary, Poland and the Czech Kingdom met in Hungary in the palace of Visegrad, which is located north from Budapest, and they agreed on political and trade cooperation. Let me note, that was the time when the Koryo Kingdom existed on the Korean Peninsula, shortly before the reign of Kongmin Wang. The cooperation of the Visegrad countries reborn 31 years ago, and all of us are developing successful ties with South Korea. Ladies and gentlemen, let me welcome all of you here again, and let me say thank you to the staff of the 4 embassies for their work to prepare the event today. Thank you very much. Have a nice time.
Thank you, Mr. Ambassador. Next, His Excellency Gustav Slamecka, Ambassador of Czech Republic, will give a welcoming remark.
Good afternoon, Ambassador Min Won-ki, my colleagues from Hungary, Slovakia and Poland, distinguished guests. Let me first congratulate Hungarian Embassy on organizing this very interesting event. So it will be, I think, interesting for everybody to see how the clean energy can nicely blend with the melodies and flavors. And I think that this idea really reflects how our countries are, because we are at the same time trying to really improve in our technological capabilities, but we still keep a good tradition in classic music, in food. So hopefully this will only demonstrate whether we are successful in that. We fully recognize that Korea is among world leaders in scientific research and development and applied science. Czech Republic considers this area a priority as well as is a key precondition to economic competitiveness. As a follow-up to conclusion of Memorandum of Understanding between the Ministry of Science, ICT and Planning of Republic of Korea, International Visegrad Fund plus respective ministries of V4 countries, which was signed back in 2015, numerous Czech entities present their draft of projects in format V4 plus Korean Republic. The Czech Republic has also been engaged in a Korean program, knowledge sharing program, between the Republic of Korea and V4 countries back in 2020 and 21. The Czech participations in the KSP program is roofed by the Ministry of Industry and Trade of the Czech Republic. This year, our ministry successfully submitted its project Smart System Resilience 4.0. Czech science has a long tradition and good reputation. There are many renowned scientific centers in the Czech Republic that are working on development of advanced technologies. Therefore, the Embassy of the Czech Republic in Seoul, together with the Czech Invest and Czech Trade Office in Seoul, proclaimed the year 2020 as the year of Czech excellence in South Korea. The objective of the above-mentioned project is to further strengthen the existing research and development cooperation between our country and the Republic of Korea and introduction of prominent Czech R&D centers of excellence to relevant Korean counterparts. We note with pleasure a large content of our bilateral relations, which include, among other fields, the science, innovation on modern technologies, research cooperation. This cooperation is based on a number of memorandum of understandings. A representative example worth mentioning is the Technological Agency of the Czech Republic, which signs memorandums with KIAT and KETEP. It also administers specific programs, Delta and Delta II, that facilitate cooperation of Czech and non-EU Czech research teams in various fields. And there are joint project calls between the Czech and Korea. Last week, the Technology Agency of the Czech Republic has launched the first call for the program for applied research, experimental development and innovation within Delta II. We believe that in science and technology cooperation, emphasis should be put on commercialization of new technologies and inventions. Data show that Czech science and research has progressed over the last decade as far as its production capabilities and international recognitions are concerned. We are convinced that working together with international partners on mutually beneficial basis and sharing best practices in this regard is a very effective avenue to expand our long-term relationship. Thank you for the attention.
Next, His Excellency Jan Kudryavy, Ambassador of Slovakia, will give a welcoming remark.
Good afternoon. Dear participants, colleagues, distinguished guests, ladies and gentlemen. Let me appreciate first Hungarian presidency for organizing this event on clean energy research, which can contribute to deeper scientific collaboration between our 4 countries of Visegrad and Republic of Korea. We live in the time when even the largest and richest countries are not able to generate all the knowledge they need. However, thanks to international collaboration, the acquired knowledge can be diffused around the globe and contribute to solving grand societal challenges, including the most urgent ones, protection of environment. In reaction to that goal, Slovakia with other partners has pledged to reach climate neutrality in 2050. Achieving this will require major transition throughout our economies and societies as it is envisaged by Green Deal. Our strategic documents in the field of national research and innovation are from now on focused on decarbonization of the economy, battery technologies, alternative fuels, low carbon industrial processes and materials. Primary task will be affordability of new alternative sources of energies and fuels where hydrogen can serve as a best example. Slovakia's national hydrogen strategy is based on the support of full hydrogen cycle, including production, distribution, storage, and use. This strategy foresees the major role of the research and innovation focused on new materials, fuel cells, green production and distribution of hydrogen, and management of risks and safety. We have also established a new research center for hydrogen technologies, bringing together major partners from the Slovak Academy of Science and Slovak universities. I'm pleased that you will hear more about this from participating Slovakian experts. Republic of Korea, which is one of the most important business partners of Slovakia, has already proved remarkable achievements in this area, and it has a great potential for further development in the future. Thank you very much for your attention.
Thank you, Mr. Ambassador. 스크린 내려주시기 바랍니다. Ms. Arleta Wdowska, Charge d'Affaires of Poland, sent a video clip of welcome message. Let's watch it together.
Your Excellencies, distinguished guests, ladies and gentlemen, Anion Hashimnika. It's a great honor for me to welcome you at today's conference, Green Energy, Flavors and Melodies, which has been organized by the V4 embassies in Korea. I would like to especially welcome Mr. Won Ki-min, MOFA's STI Ambassador, and Mr. Martin Sherbel, Deputy State Secretary at the Hungarian Ministry of Foreign Affairs. I very much regret that I cannot be physically with you today. The main purpose of this conference is sharing information on recent clean energy R&D projects conducted in the V4 countries. This is another area that we share not only among the V4 countries, but also with Korea. It's also another area with great potential for enhancing cooperation. In the second part of the event, you will be able to enjoy a cultural performance and taste what is most famous in Poland, Polish traditional alcohol. I hope it will be an incentive for you to find out more about Poland and about the V4 countries. I wish you a very pleasant afternoon.
네, 스크린 올려주세요. Congratulatory speech will be given by His Excellency Won Ki-min, Science, Technology and Innovation Ambassador of Ministry of Foreign Affairs in Korea.
Good afternoon. His Excellency Mr. Martin Schebel, Deputy State Secretary of the Ministry of Foreign Affairs and Trade of Hungary, His Excellency Dr. Mose Chomer, Ambassador of Hungary, His Excellency Mr. Gustav Slameska, Ambassador of the Czech Republic, His Excellency Mr. Jan Guderiabi, Ambassador of Slovakia, Ms. Arleta Budzujowska, Charge d'Affaires AI of Poland, Dr. Istvan Sobor, Vice President of National Research, Development and Innovation Office of Hungary, Mr. Hwang Deok-soo, International Director of National Research Foundation of Korea, distinguished participants. It's a long list, isn't it? Welcome to the Clean Energy Plus Flavor and Melodies. I am Min Won-gi, Ambassador for Science, Technology and Innovation of the Ministry of Foreign Affairs of the Republic of Korea. It's my great honor to deliver opening remarks at this public diplomacy event between the Visegrad 4 and Korea, organized by the Hungarian Embassy in Korea under its presidency of the Visegrad Group. First of all, I would like to express my special thanks to the heads of missions of the V4 countries in Korea for their warm welcoming messages. I would also like to thank all the speakers for the mini-conference, the Clean Energy Research V4 and Korea, for joining us to share their valuable insights. Distinguished participants, today, as a response to the climate crisis, countries across the globe are announcing ambitious carbon neutrality goals and deliberately preparing measures to achieve them. Korea has also joined the global efforts. At the COP26 summit held in Glasgow, UK in 2021, the Korean government announced an updated NDC, which aims to reduce national greenhouse gas emissions more than 40% compared to the 2018 level. Western European countries had already reached the peak in their greenhouse gas emissions in the 1990s and have worked to reduce emissions since. Compared to this, Korea has set an aggressive and challenging goal to reduce such an amount of emissions within a very short period of time. As of 2019, 83% of the global greenhouse gas emissions came from the energy sector. Within Korea, greenhouse gases emitted from the energy sector account for 89% of the total greenhouse gas emissions. It has indeed become an unavoidable obligation of us to accelerate the transition to clean energy so as to leave our future generations a sustainable planet. To address this challenge and achieve our ambitious goals, science, technology, and innovation should be at the foundation. The importance of science and technology has increased more than ever, and the new Korean government also declared its will to implement science and technology-based policies to respond to global issues such as pandemic and climate change. Cooperation in the field of science and technology, including climate change responses, 5G, 6G, quantum computing, and biotechnologies, was one of the major agenda items during the Korea-US summit held in Seoul last weekend. Distinguished participants, Korea is expanding its R&D investment in various climate technologies to accelerate the clean energy transition. In particular, the Yoon Suk-yeol administration, inaugurated on May 10th, has announced its policy priorities, and they include an increase in R&D to secure new strategic technologies such as small modular reactors, the generation for nuclear reactors, nuclear fusion, and hydrogen production from nuclear energy. The priorities also include an early commercialization of new energy industries, including carbon capturing, utilization, and storage, and clean hydrogen by strengthening the foundation for its production and supply. Now is the moment where national R&D institutions specialized in clean energy, such as the Korean Atomic Energy Research Institute, the Korean Institute of Energy Research, the Korean Institute of Fusion Energy, and the National Research Foundation should play an even greater role. Against this backdrop, it is timely that the mini-conference, the Clean Energy Research, has taken place as a public diplomacy event between the V4 and Korea. Moreover, the cultural program about the V4 countries will enhance mutual understanding between the two parties. The cooperation momentum between Korea and the V4 has become all the more stronger thanks to the Korea V4 summit held last November on the occasion of a Korean president's visit to Hungary. Also in December 2021, the governments of Korea and the V4 countries signed an MOU on research cooperation in the fields of science and technology as a follow-up of the summit. I recall that after that first Korea V4 summit in December 2015, we carried out joint research on 5 topics in chemistry and chemical engineering. Just as it went successful, I expect that the two parties, this time too, will identify diverse topics of joint research, including clean energy, and produce outcomes that will bring substantial benefits to both parties. Since the V4 countries have a competitive edge in basic science, and Korea has a strength in applied science, I have no doubt that the mutual cooperation between our two parties will create great synergy. I hope we explore R&D cooperation opportunities today to identify specific joint research topics, and I also hope that this event will provide an opportunity to deepen Korean people's understanding of the V4 culture. Last but not least, I appreciate the leadership of Hungary demonstrated throughout the last 1 year as the presidency of the Visegrad Group. On behalf of the Korean government, I also express my deepest gratitude to all the staff members of the Hungarian, Czech, Slovakian, and Polish missions in Korea who have made tremendous efforts to put this invaluable event together. Thank you very much.
Thank you, Mr. Ambassador. 스크린 내려주세요. Next, His Excellency Maraton Sheberu, Deputy State Secretary of Ministry of Foreign Affairs and Trade in Hungary, sent a video clip of his congratulatory remark. Let's watch it together.
Dear participants, ladies and gentlemen, it is my privilege to welcome you at the Clean Energy Research Science Diplomacy event organized by the Hungarian Embassy in Seoul as President of the Visegrad Cooperation. Finding new perspectives, strong commitment for innovation and cooperation, in my opinion, are the very essence of the Visegrad Group itself. The establishment of the V4 Group itself was an innovative project 30 years ago. The last decades proved the founding fathers right. The cooperation has become a relevant actor in Europe and globally as well. Although the issues, the interests, and sometimes the intensity may have varied from time to time, research and development have remained an evergreen topic. Hungary, in its role as president of the group, has been focusing on strengthening partnerships. The V4 countries have always been proactive in creating a coherent research, development, and innovation framework, and Korea has been an exceptional partner of the V4 countries in that for decades. The history of Visegrad Group's joint commitment meetings on science and technology with Korea look back to 1989. Research communities of the V4 countries and Korea have been working together for 3 decades now in diverse areas of basic and applied research, including chemistry, celestial bodies, lasers, and materials. The new stage of this cooperation between the Visegrad Group and Korea was launched by signing a research cooperation MOU in Hungary in the last December. Consultations have already started in order to establish a new program starting in 2023 to support new V4 Korea joint research. Korea is an esteemed partner for us. Its achievements in the knowledge-based economy is a model we definitely would like to learn to follow. As far as Hungary is concerned, the re-elected government has committed itself in its RDI strategy to increase research and development expenditure as a share of GDP of 3% by 2030. In Hungary, the restructuring of research institutional network, the establishment of university innovation ecosystems, and the newly established network of national laboratories are all important milestones in achieving our main objective to make Hungary a strong innovator country. Looking at the wide range of programs today, I'm convinced that this conference offers an opportunity to establish new contacts, exchange views on outstanding issues, and opens the window for further cooperation. It is an excellent forum for sharing good practices and exchanging experiences of strategic importance, such as clean and green energy, especially today, when the diverse energy policy is on the mind of us all. Therefore, I hope that the discussion today will provide all the participants with relevant information and paves the road for further cooperation. Thank you very much for accepting our invitation and participating at this event, and I wish you a successful conference. 감사합니다.
네, 스크린 올려주세요. Before we start the first session, we'd like to take a group photo. Excellencies, all the speakers and presenters, please come up to the stage. Thank you. Now we begin the conference. 스크린 먼저 내려주세요. Now we begin the conference with the opening speech delivered by Dr. István Szabó, Vice President of National R&D Office in Hungary.
Yes, thank you very much, Your Excellencies, dear colleagues. It's a pleasure being here, though online. I have made a brief presentation to provide an insight on what we see as potential for cooperation and how we see our cooperation opportunities for Korea, both in the V4 level and both on the Hungarian level. Just a short remark maybe about our office. In Hungary, there has been a recent structural changes in the governmental structure. So now we are operating under the Ministry of Culture and Innovation. Previously, we have been operated under the Ministry of Innovation and Technology, but our duties are basically remain the same. So we are both active in policymaking and both active in carrying out funding schemes and basically making grants schemes as well. Just a rationale why cooperation is important for not just for Hungary actually, but for the V4 countries as well. With Korea, on this chart you can see the EU countries in blue and the non-EU countries in red, and you see that Korea basically excels in terms of the global brand value of top 5,000 companies worldwide, and also in the gross expenditure on research and development, while most of the EU countries are lagging behind. And also, as you see, if you take a look at not just on Korea, but for the other countries in red as well, that those countries which excel in innovation in terms of global brand value are mostly outside Europe, and this is basically called the European paradox. But Europe is strong in research and development, but is not strong enough in innovation, and this is something what we would like to change somehow. If we scope a bit on the European level innovation, There you can see that it is a comparison of how the innovation performance and on the gross expenditure research and development for the EU countries. And here you can see that there is or there are two groups of countries basically. One of them is again access in innovation. These can be seen in the top right part of this chart, and the other ones are basically pretty much in the middle part of these countries, though they are spending quite a few on R&D, but still can't make the breakthrough in innovation. And this is mainly because the transition activities are a bit lacking, or we are trying to build these, but still we have to make dedicated efforts to make sure that we will excel in innovation as well. And what we see as a key for this is internationalization. And why Korea? Korea basically is a partner from which we can learn a lot, because Korea undoubtedly excels in innovation. And as you see, among the V4 countries, in the emerging innovator categories, there are 3 countries, including Hungary, and also the Czech Republic is a moderate innovator as well. So all the countries in the V4 are behind the EU average. And besides the 3% GDP spending on R&D as a goal for 2030, we in Hungary at least would like to make sure that we will be strong innovators by 2030, which is quite an ambitious goal. So this means that basically we should make one step up each year, but it's quite obvious that we can't do this alone, and this is true for the other countries in the region as well. What we are trying to do is to form a sort of critical mass, and the critical masses which we are forming are the already mentioned national laboratories, for instance, because these are sort of one-stop shops for R&D cooperation with the international partners. This means that if, for instance, you take the Artificial Intelligence National Laboratory, or any other one basically, then you have a single point of contact, through which contact point you have access to all the relevant partners in Hungary. So you don't have to find on a peer-to-peer basis the potential cooperative partners, but rather you have, again, as I mentioned, a single entry point, and we hope from this that international cooperation can increase because of easier access. And of course, it also helps boosting cooperation within Hungary in these thematical fields as well. A new initiative which might be more relevant actually for the clean energy topic is the system of science parks, which are currently under construction. Here you can see many topics which are closely connected to the clean energy. For instance, in Nagykanizsa, you see in the lower left part of the chart is the recycling economy, renewable energy, but also in the top right part of the University of Miskolc, you see sustainable development, environment, waste management, and these are again in the mind with the mindset, formed in the mindset to have a single point of contact. And it's very important that in the framework of science parks, there should be, in each case, business partners present as well. So these are not solely for R&D, but mostly for innovation, actually. And I think that this can be very good partners. But since I mentioned we would like to raise the region's innovative capacities as whole as well, we are very much eager to build the broader collaborations among the V4 countries, and here you can see what we did actually, and there are already certain actions and consultations which can again be connected to the clean energy topic. And there are initiatives, for instance, like the so-called BioEast initiative, which does not only include the V4 countries, but all the V4 countries are there as well, which, for instance, target the biomass-based economy. So the clean energy topic is, I would say, a thing in the V4 level. And the logic behind is, again, that from abroad, sometimes the V4 countries just by themselves are not necessarily visible enough, I would say. But if we form a critical mass, and this is the V4, then we can build a much more intense cooperation. And actually also the logic of V4 helps a lot in gathering resources, pretty much similar to the logic of the national laboratories or to the science parks, that if you have a single contacts for the V4 countries, this means that you can have access for the research and innovation capacities in all of the V4 countries, and you don't necessarily have to connect them again by from country to country. And this was basically the scope of the Science and Technology Memorandum of Understanding, which was signed with the Visegrad Group. You see here that in 2016 there has been a joint call for proposals, and now we are planning the second call, as it was mentioned, and a potential research area is clean energy. And I'm pretty sure that in this event you will find good ways and good rationale to build on that. Clean energy should be actually a thing or a topic around which the applications could be built, because besides building critical mass, what we see that in each case, when there is a dedicated research area to which you can provide your financial funding, basically, it is much more effective than just to fund everything, because it's more efficient that way. So with this, I would like to thank you for attention, and I really hope that there will be many projects from the field of clean energy in the future, and I wish you a good conference. Thank you.
Dr. Sabo. Now, please welcome Mr. Deok-soo Hwang, International Director of National Research Foundation of Korea, for an opening remark.
Good afternoon, Honorable His Excellency Ambassadors, and ladies and gentlemen, and good morning from the respectable participants from the Visegrad member countries. My name is Hwang Deok-soo. I am Director of the Office for the International Framework at the National Research Foundation of Korea. I'm very pleased to introduce our foundation and to present the cooperation status between Korea and the V4 countries on this beautiful occasion. Very recently, I read a research policy report. The researcher from a Korean R&D Research Policy Institute suggested to make use of our Korea V4 cooperation as a good way of participating into European framework program, Horizon Europe. It could be very good alternative for Korea. This is the content of my presentation. I will briefly review an overview of my foundation. As you see here, our foundation is located under the two ministries, Ministry of Science and ICT and Ministry of Education. We are funding for research activities in universities and public research institutes. Our vision is to become a global leader in research funding with making sustainable, healthy research ecosystem. This is the organization structure. As a foundation, we have a board, and president is CEO. There are 7 different directorates which cover all academic areas from humanities, social science, into science and technologies. This is the budget. As of 2021, our budget is approximately $6.4 billion US. As you see here, basic research and research training in universities, and national strategic R&D programs are three main pillars of our funding, taking more than 90% of the budget. As a representative funding agency in Korea, since the establishment in 1977, we are very active in international cooperation. Currently, we have the 81 partner agencies of 51 countries worldwide. Based upon the cooperation development strategy, we are operating various kinds of the international programs, as you see here. Now let's move to the second part. I will briefly introduce the Korea V4 Cooperation Program. This is the outline of the first Korea V4 Cooperative Research Program. Based upon the MOU signed between our foundation and 4 respective partner organizations of 4 countries, we funded the program from 2017 and 2020 for a 3-year project. And we are, as just my colleague from Hungary announced, we are planning for the next round of the cooperation. Okay, through the first cooperative program, we have achieved very good academic performance, as you see here. The 16 SCI journal papers have been presented, and 119 international conferences are held. These are the list of the recipients of the first program. 5 researchers with the 5 Korean researchers with their counterpart in V4 countries. Finally, I would like to introduce some comment from the researchers who participated in this program. Professor Kim Soo-young from Korea University, he commented it was a good chance to visit National Research Institute from each country, and it's a good momentum to inspire his students for the research landscape in 4 countries. Also, Professor Jung Do-soo from Seoul National University, he achieved quite very good academic, papers. He commented they are very friendly in research cooperation, and the program satisfaction was very high. Also, Professor Dr. Jung Young-sik from Korea Research Institute of Chemical Technology, he was also very satisfied with this program. He mentioned like that, based upon the V4 program, it will be very helpful for cooperation with European countries. Really, as a step in Korea Funding Agency, we really expect the Korea V4 cooperation in the future. Based upon our cooperation, we would be very active the participant in the European framework program. So we are expecting this cooperation more advanced and more prospectable in the future. Thank you for your kind attention. Thank you very much.
Thank you very much. We are now continuing our program to the next agenda. That is to hear the keynote speech, which will be delivered Dr. Ákos Horváth, Director General of the Center for Energy Research of Hungary. The topic of his speech is the security of energy supply in the 21st century, V4 collaboration in the field of nuclear reactor development.
Thank you very much. Thank you very much for the invitation. Also, dear Excellencies and dear colleagues, I would like to thank for the invitation in the name of the group which I'm representing today. This is the V4G4 Center for Excellence. It is a true Visegrad 4 collaboration, and I would like to share my screen with the presentation. I hope you can see my presentation now. So the title of the talk is the security of energy supply in the 21st century. And this talk is about a cooperation on nuclear research on nuclear energy, and specifically, this is the Allegro project. It was first launched within this group more than 10 years ago. And this V4G4 Center for Excellence is founded by 4 institutions within the Visegrad region. In addition to that, CEA, the French CEA Institute, is a great supporter of this group. In my talk, I would like to briefly introduce you the project and the rationality for such research. And then very briefly, I would like to show you the goals and challenges, scientific challenges behind this idea. And finally, some information about the present funding. As in Korea and also in the Visegrad region, we all know very well that nuclear energy will have a role surely in the future in our energy mix, because we all would like to use effective and cheap source of energy to be sustainable for the future, and also producing energy by clean devices, clean sources. However, for the long run, I mean several decades or even centuries, for the long run, the nuclear energy has at least 2 challenges. One of them is the supply of the fresh fuel, and also the management of the spent fuel. We speak about the advanced reprocessing of the spent fuel. At present, we just pile up the spent fuel, so there is no final solution. The scientific communities very much believe that the proper management, advanced reprocessing, will give us or the humanity a proper management on the long run. What we also believe within this group, V4G4 Center for Excellence, that fast reactors will provide a solution for that for those challenges. And what fast reactors could offer us, at least more efficient use of the fuel. This is one of the main important features. Also, the reduced volume of radiotoxicity of the spent fuel or high-level waste. It is by means of the advanced reprocessing. What does it mean, advanced reprocessing? In our case, it means that comparing to the present technologies, besides the uranium and plutonium, the other minor atomites will be extracted also from the spent fuel, and then we would like to transfer them into less toxic form of waste. Fast reactors is not a new idea. They were developed several decades ago, from the very beginning of the history of nuclear energy. But there are some undesirable features of some of them. For example, the sodium fast reactors have some safety problems, weight coefficient problems. And also, when we use other liquid metals as coolant, they have some toxic troubles and so on. So the handling of such liquid coolant is not obvious, not trivial. But the gas-cooled fast reactor, in our case, gas means helium. Provides some positive feature comparing to the others. Therefore, we would like to go in that way, and we would like to introduce the gas-cooled fast reactor, the helium-cooled Allegro, and the gas fast reactor concept. So the Allegro project was first launched within this region more than 10 years ago, roughly in 2010. And it was founded by 4 institutes. Then we extended with a 5th Czech institute, and also CEA from the very beginning gave us strong support as they first developed this idea, this concept. So these 6 institutions, which the names are printed here, running this Allegro project within this V4G4 association. And time to time we are successful to get funding from the Euratom as well for our research. I would speak very briefly about the general objectives of the project, the Allegro project. Of course, Allegro is only a small machine, a small device, only demonstrating the feasibility of the technology. And for the far future, we speak about commercial design. It is the so-called commercial GFR. It is one of the so-called generation 4 reactor concepts. You can find several documentation even on internet or elsewhere about the GFR. So this small Allegro device is the main objective of our research. So we would like to first demonstrate the technology. Also, we would like to build up this machine because we need a test bed, a testing machine for the future materials development. We speak about structural materials, but also speak about the nuclear fuel, which will be an innovative one for the next generation. And also we would like to demonstrate with this smaller machine at the same time the feasibility of using a nuclear device for high temperature industrial applications like hydrogen production, thus providing a cheap source of heat for the industry. Going in the details a little bit, the design overview, you can see that first of all we have to focus on the existing materials, the existing nuclear fuel. So we are following a 2-step approach. We would like to first build up, construct the machine with the existing technology like MOX fuel, in order to run and provide a test bed for the development of the next generation innovative fuel, which will use silicon carbide as a cladding, because with this innovative fuel we can reach then the final target outlet temperature at 850 centigrade. This device is designed with a very high power density, roughly around 100 megawatt per cubic meter. And of course, as this is a generation 4 machine, it should be designed with the maximum safety, the so-called passive safety systems. Some specific challenges, just a brief overview. They are very interesting for those scientists who work in the project, providing very interesting topics for the young experts as well. Among the specific challenges, you can find some from the material sciences and also some technological challenges. And even reactor physicists who are theoretical scientists, they can find their challenges as well. How to control such a machine, how to operate such a machine. Some pictures about the safety concept. We think that this small machine, the Allegro, it is small enough to put in a big guard vessel. And this guard vessel will provide us the ultimate safety. So in case of loss of the coolant, the loss of the helium gas, this guard vessel will be able to close all the toxic coolant during the transient, for example. The decay heat removal system has the role also to remove the high heat energy in case of a severe accident. So such a device should be designed with the maximum precaution, and also we have to try and test before the final use. There is also an emergency coolant injection in case when we have a pipe break and we lose the gas as coolant. We need this emergency coolant injection system. Some remarks about this guard vessel. We think about even a pre-stressed concrete or a big steel containment. We develop in both versions, and this big structure will work normally at atmospheric pressure, and in case of a severe accident, this pressure can go up to the 10 times the atmospheric pressure practically. So this is not a big challenge to provide this guard vessel in that form. LOCA in slide means loss of coolant accident. So such a machine, the gas fast reactor, safety questions are very important ones, and as Allegro is a first of a kind machine, then we have to be very careful. Also, we had to redesign this machine after the Fukushima accident. Because also the safety also provide much stricter rules, so we had to change a little bit and redesign the machine. In case of loss of the electric input, we have to provide also a battery powered blower for the continuous operation of the active passive systems as well. A few words about the group itself, which are working on this concept. The V4G4 Center for Excellence has a board, consists of the leaders of the institutions, and also the group of scientists together with this board have a meeting 3 or 4 times a year. Even those times when we don't have external funding, we meet regularly, and we run this project on the own sources of the participating institutions. We developed a kind of roadmap document where we summarize the goals and also the topics to be worked out, and the priority of the different R&D challenges. We run, as I mentioned, even if we don't have the external funding, we run at our funding, or even the respective institutions try to get some national funding, government funding in their respective countries. So the main challenge in that case is to synchronize the activities when one of the parties have no external funding or no national funding, and even we try to put as much capacity as we can in the project in order to reach the goals within a limited time. For the GFR as a commercial facility, we of course we know that as this is still a concept to be worked out, it is not so attractive for the industry at the moment, so the private industry. So we have to find the government tools for working on this project. Nowadays, we have the possibility to apply for European grants Euratom is funding similar projects time to time. Of course, it is not a guaranteed funding, but now I can present you that Euratom accepted our application 2 years ago. So we are now running the so-called SAFE-G project. SAFE-G provides financial background for our Allegro project. SAFE-G is a scientific project, so it has a lot of work packages around the scientific challenges from reactor physics, thermohydraulics, or even material sciences. And also Euratom requires activities in the field of education, training, and exchange of visiting scientists. So we also put those activities within the project, and you can see a brief overview of the different work packages. We also opened the door to other interesting companies, universities. You can see the logos.
Dr. Horvat, sorry
Yes.
to interrupt you, but due to the limited time, would you please wrap up your presentation? Thank you
Yes.
very much.
Yes, this is the last slide of my talk. So this SAFE-G is currently running with 15 organizations, and it will end in 2024. Okay, so thank you for your attention. It was a brief overview of this nuclear research program running by the Visegrad 4 institutions. Thank you.
Thank you very much. The first presenter is Dr. Andros Tompos, Director of the Institute of Materials and Environmental Chemistry of Hungary. The topic of his presentation is energy-related research activities at the Research Center for Natural Sciences.
Yeah, thank you, dear colleagues, Your Majesty ambassadors, and I try to share the screen. Thank you for the possibility to show our activities in the field of renewable energy. First of all, before I start my presentation, I would like just to mention that briefly in a few weeks, hopefully a new national laboratory will launch called Renewable Energy National Laboratory. It is a consortium of 11 research sites in Hungary, universities, and hopefully in the next occasion, there is a chance to introduce activity of these research sites to potential Korean partners. But now, what I would like to show you is the activity of the research center. So we developing proton exchange membrane fuel cells, mainly some of the components. For example, we developing electrocatalysts that are CO tolerant or durable with low platinum content, and also we focus on development of proton exchange membranes in order to substitute the present used Nafion membranes. So for this application, we would like to accelerate research and development activity by means of high throughput techniques. So we have 16-channel potential state, and we developed a 6 to 12 member short stack. And we have a proprietary optimization algorithm that can be accomplished with partial least square regression and artificial neural networks. These are data mining tools that can correlate the performance of the fuel cell to preparation variables or composition of the electrocatalyst or the membrane. So by means of high throughput equipment, we can accelerate the research and development activity, and the parallel analysis of the fuel cell components can be achieved within a short time. So we can submit the stack and materials to accelerated aging tests according to different dynamic load cycles that are well known, for example, in automotive application, but also stress tests for other applications, such as, for example, grid balancing, can be developed and applied. We focus on degradation mechanism upon dynamic load cycles, and these degradation mechanisms are discovered by means of electrochemical techniques, such as, for example, electrochemical impedance spectroscopy. It can be done in situ operando during the measurement, and it can be used to monitor the transport processes taking place, and these changes of transport processes upon degradation. We use also cyclic voltammetry for monitoring the changes in the active surface area. Another research group is active in the field of lithium-ion batteries, and recently they are developing a novel carbon-sulfur composites with cutting-edge carbon.
Dr. Tomposh, we cannot properly
Yes?
see. We cannot properly see your presentation file. Would you please close it and once reopen it again? Your presentation file, yes.
Yes, I stopped sharing.
And then reopen it.
Sorry, reopen. Okay, I try. I don't know why. Does it work? I reopened and sharing. Unfortunately, yesterday during the test, we had the same problem, and I don't know if it is resolved somehow. So I try again. Can you see our second slide?
지금
Or the
잘
third
되나요?
one? Still the title.
No, not working well. Just a moment, please.
Not really.
Please push the slideshow. The slideshow button.
Yes, I do it, but I don't know why.
지금 작동합니까?
Try again, okay.
됐습니까? Yes, it's working, Mr. Tombosh. Thank you very much.
Yeah, but now I cannot change the slides. You can see only one, and I cannot
okay.
change them.
지금 슬라이드가 안 넘어간다.
So the problem from my side. Still don't know how to resolve it.
확인되시나요?
Probably you have an idea of what can I share. I try to share the screen.
Yeah, the technician is figuring it out. Please wait.
Okay, now, I think now it will work because I shared the screen. Can you see?
지금 보이시나요?
Only me.
됐나요? Yeah, it works. Thank you very much.
It works.
Yes.
It works. So this was then the resolution of the problem. I have to share the screen and not the presentation. Anyway, so we're developing carbon sulfur composites for high cycle life lithium sulfur batteries. We are using for this purpose cutting edge carbon nanostructures, nanotubes, nanosheets, graphene based on graphene, graphite oxide, and so on, in combination with elementary sulfur, and using chemical and physical confinement strategies And the group is aiming to formulate high cycle life capable lithium sulfur batteries, mainly for stationary application. In a second topic, we move toward the solid state, quasi-solid state battery system, and in this way enhancing the intrinsic safety of newer generation batteries. The lithium conductive polymer matrices, we hope they will be suitable for to host the high cycle life capable carbon sulfur composites or any other high energy density composite positive electrode materials. We are also actively working on investigation of electromechanical aging of the thin films, and we probably will focus on substitution of critical raw materials. We try to implement secondary raw materials in electrochemical energy storage. Stay at the still at the carbon nanostructures and such as nanotubes, nanosheets. We investigating its applicability for energy storage, for electric double layer capacitors, also called supercapacitors. They're made of carbon nanomaterials and exhibit sufficiently high power and energy density, which bridge the gap between the batteries with limited power and density and conventional capacitors with limited energy density. And such device might be used in electric vehicles and in electronic communication devices. So not only the material science is done at this research group, they are focusing on developing test systems, apparatus that on-build apparatus for fast characterization of carbon-based and hybrid supercapacitors, electrode materials, electrochemical impedance measurement system employing multi-sign perturbation capable of fast performance characterization for inline process, as well as long-term stability measurements in sustained application is applied. Okay, and we have a research group dealing with phase change materials, and recently organic phase change materials are microencapsulated, and this technique was scaled up to a quite large scale, 100 kilograms per hour production capacity. The mechanical and thermal properties of PCM loaded microcapsules are improved by changing the preparation parameters and using novel additives. And these microcapsules are integrated into building elements, and their heat storing properties are studied in environmental friendly lightweight buildings, large panels, and prefabricated houses. Recently, the research group turned its activity towards bio-originated PCM microcapsules for packaging materials for cooling applications. The size and morphology of the materials are characterized by laser diffraction and scanning electron microscopic methods. Solvent extraction is used for determination of the PCM content, and the thermal analysis is performed by thermogravimetry and differential scanning calorimetry. And obviously, even in this case, long-term use is also tested by accelerated thermal cycling test. Last but not least, one of the research groups is dealing with hydrogen storage by means of different liquid organic hydrogen carriers, such as, for example, the dibenzyl toluene shown on this slide. We developing both the heterogeneous catalysts for the processes and the process as well. new noble metal field catalysts are developed, and the technology is developed. We designed a suitable reactor system for the process, and it consists of not only the reactor with monolith, but also a gas liquid separator, liquid pump, and heat exchanger. By this, I would like to close my presentation, and thank you for your kind attention.
Thank you, Dr. Tompos. The next presenter is Mr. Lukáš Novotný, SMR expert of the Ministry of Industry and Trade of Czech Republic. The topic of his presentation is pink hydrogen production opportunities.
So, hello, good morning, good afternoon. I would like to share the presentation. Hopefully you can see it. So, dear ladies, gentlemen, colleagues, Ambassador, my name is Lukáš Novotný and I'm from Ministry of Industry and Trade. And today I would like to talk about pink hydrogen production opportunities and how we see the hydrogen in the Czech Republic. So, at first, with the context of the EU, last Wednesday, Repower EU was published, and there is a quite important sentence for us, and that is that the preferred production of fossil fuel hydrogen with notably the use of nuclear and renewable sources. This is quite important for us because nuclear was usually diminished of the importance in the EU, and there was a main focus on the renewable sources, which we understand we do prefer them too, but there is a possibility to use nuclear power plants for the hydrogen production in the future, and it's important to see this possibility and do something about it. In Czech Republic last year, there was a Czech hydrogen strategy published, and we project consumption of 1.7 million tons of low carbon hydrogen by 2050. So this would require additional 95 terawatt hours of electricity to meet this hydrogen demand. You would expect the main demand would be on the side of production of electricity and heat, but we suggest that the main consumption will be in the industry of transport and followed by metallurgy. So in the transport, we'll see increasing consumption year by year, starting with the year 2030 and increasing every year. The main consumption in the transport will be made by trucks and then usually the public transport. So this is the industry we have to provide hydrogen for, and it's the most important for the CO2 lowering in the future. So as I mentioned earlier, there will be additional 95 terawatt hours needed annually. This would require doubling energy production in Czech Republic. Also, right now, we'll see the main source of energy in Czech Republic is coal, with 30%. This huge portion has to be replaced by 2033 because of the coal phase out, and we'll see how we will change our energy production mix. We do expect to build one nuclear power plant at least. Right now the tender is ongoing for the Dukovany nuclear power plant, and we will see a huge build in the field of solar power plants, and possibly wind turbines. So when we talk about production of hydrogen from nuclear power plants, the main possibility how we can produce hydrogen is with electrolysis. There are two possibilities. One is low temperature electrolysis. The second one is high temperature stream electrolysis. With the low temperature, we can use alkaline proton exchange, alkaline electrolysis, and proton exchange membrane. Those two technologies are quite well known, but currently they are not economically competitive, which they can be in the future, but we will need a lot of research and development in this field. The second possibility of electrolysis is high temperature stream electrolysis with up to 90% of efficiency, which is way more than the usual low temperature alkaline or proton exchange membrane technology. And this technology right now is not used because of the current fleet of the used reactor. We would need generation 4 reactors for those temperatures to reach, and those can be reached with classical PBR reactors. So in the future, probably with incoming SMRs, there will be potential to use high temperature stream electrolysis. The last possibility how to produce hydrogen from nuclear is with high temperature splitting. This is a thermal decomposition with at least 2000 degrees, which is quite a huge number, especially for nuclear power plants. So with this technology, the molecules are split directly without electricity, but if we can't provide sufficient temperature, we can't do this process. This is the reason why we are trying to do more research in the field of hybrid cycles, where with the high temperature, the use of electricity lowers. So, for example, with hybrid sulfur processes that operates at temperatures of 5 to 600 degrees, we consume just 25% of electrical energy in compared to electrolysis. So there you can see on the graph what is the technology readiness and economical viability, and with the nuclear, both electrolysis and high temperature splitting is in the middle with technology readiness 4 and 6, and economical viability 5 and 6. This can change in the future with technology improvement, with the development, and maybe with the different energy mix, not in the EU, but in the world, because the world is quite shifting from the natural gas to hydrogen. So there's a possibility to evolve the technology and use it more sufficiently. And yeah. So right now, the position of Czech Republic, we do welcome and support the EU Repower initiative. We also support the taxonomy with the use of nuclear power plants, builds, and the possibility of hydrogen production. But right now, there are currently no commercial activities related to hydrogen production from nuclear plants, mainly due to economical value, and maybe we will see the shift in the future. So right now, the preferred way for the Czech Republic is to produce hydrogen from electricity grid, and there will be used mainly the low carbon electricity. Thank you very much. This was just a brief overview to let you know what we are doing in Czech Republic. What is our view?
Thank you, Mr. Novotny. The next presenter is Mr. Sebastian Bikoch, Head of CASO for Research from Research Center for Energy Conversion and Renewable Resources of Poland. The topic of his presentation is smart energy systems for local communities in urban and rural areas.
Hello, everyone. My name is Sebastian Bikoch, and I will tell you about our work that we do in the Polish Academy of Science in our research institute, and especially in a CASO Research Center. Let me now just turn on my presentation. I hope it is visible. Okay, so smart energy systems for local communities in urban and rural areas. And I will tell you shortly about the research project we do in this topic. Our research center is a newly established facility near Warsaw, and this is a part of the Institute of Fluid Flow Machinery of Polish Academy of Science. And this demo site, this facility, is actually a test site for new technologies in development, testing, and presentation. So based on this facility and the technologies that are being developed, we are cooperating with industry, we are cooperating with local municipalities and local society, and also we are developing, of course, our own technologies. The topics that we do is mostly the renewable integration, smart energy system development, clean transportation. The last thing that we do is the energy island initiatives and the local communities, local energy communities building, and also technologies for energy storage, especially some hybrid system using different technologies for electricity storage. So how we cooperate with partners, we apply for joint projects and for joint financing. We cooperate with companies as B2B, and also we organize seminars, exhibitions of new technologies. So this CASO Research Center for us is a cooperation platform and a place for development of this smart energy system. As I'm showing now, how we understand the smart energy system. We see the system as a whole. We look at the system from the electrical point of view, from the heating point of view, transport, fuel, transmission, and production, and all of the systems from our point of view have to be treated together, and that way, using this approach, we can really go into the energy transition. As we say it now in Europe. So we, as a research center, we are in a research group, actually, we are developing some modeling tools and some models for the modeling of such systems. That's an example of such a system where you have a lot of different sources, electricity, heating, and fuel sources, combined with some renewable production and storage, production of cold, production of heating, and all of it is connected and may be analyzed during the whole year, hour by hour. And so these are the analyses that we do. That's just an example of one of them, where we can see in every hour what we produce from the renewables, how much and how we can use it, like what can we store and when, and at the end, we can calculate how much it will cost. So actually that's basically the things that we are doing, and we are implementing this approach in projects in this involving already real communities, real entities, some rural areas and cities, as I said. So, for example, the first project, it's based in a village in northern Poland. It's Gmina Przywic, where we are developing the models for determination of demands, of heating demands, electricity demands, looking at the whole municipality, as you can see here. And using our approach, we can find the places, the hotspots, where the density of heating and electricity needs are the biggest. And then we can supply some specific solutions to that region. And what we do, we have developed different tools for that. We have developed the tools for energy monitoring, energy management. That's what we do now. And actually, we are now analyzing different energy systems. We are applying the new energy systems for these local communities. And on the right side, you can see how different energy sources and demands may be met together if you mix them differently. So we can see how much biomass or heat pumps or local photovoltaic or local wind production should be implemented to meet the goals. So these are the analyses that we do. Going down to the scale, we are also analyzing the specific locations in this municipality. Locations, I mean, school or sport hall, as we see here, and we are analyzing again, going down to the scale. We are analyzing the energy flows in these buildings. So, and we are proposing a new approach for that. So, going deeper into this topic, we are part of European project, SIRIN, H2020 project that we do together with partners from Denmark and Netherlands. So we are implementing in the same municipality specific technologies. On one of the places we will be installing a mobile electricity storage. We will install energy management system. We are modeling the system, and also we try to organize the community. Also, and in the sports center, we will install 3 heat pumps, EV chargers, energy storage unit based on flow battery. And also we have organized already electric transport for children to school. And also the third case in this municipality, we are working on new services for grid using the technology that is implemented in the local sewage treatment plant. And all of these technologies will be combined somehow by smart meters and new energy community. So that's something that we do in the rural area. Another topic that we are working on now on the city level, it's something similar that we work on the level of in the city, in the municipality, in housing community, where we will install some photovoltaic system with heat pump, with energy storage as a flow battery again, 2 EV chargers, and it all will be combined with energy management system. So that will be a case for implementation of the new housing community and energy community in the future. And so the new business model has to be developed. And the goal in here is to get rid of local gas, local domestic hot water production in every flat in those buildings. And we have thousands of buildings like that in Poland and in Europe also. So another project that we do on the city level, it's something more broader. So we are developing the methodology how to get rid of the local heating systems based on coal and in the future gas. And now looking at the war in Ukraine, it's becoming more and more important now to get rid of these fuels from the cities at least, and the places where it's possible. So here we can see this whole city with the points, the yellow and red dots are the local boilers that need to be replaced with something else. And of course, we are developing new ideas. And on one side, we want to, for some of the buildings, we are preparing the idea how to combine them with the local district heating company. And for other houses that are not really in a good position, how to develop the systems that will be implemented in the private houses. So we are cooperating with district heating company. We are doing models of the whole district heating system, the heat and electricity production local. And we are now analyzing this whole utility. Of course, we are a research institution, so we are working on the papers based on real facilities. So both worlds are connected. Another project that is being used in this field is a project Hypergrid, European project, again from the Green Deal package. Where we are developing technologies, new technologies that may be implemented in the hybrid coupled networks for thermal and electric integrated smart energy districts. And so we are developing the platform for connection of this new heating and electricity system to fulfill the needs of the projects, for example, that I showed you before. So the new local heating and electricity system, heating, cooling, and electricity production and use. And all of that may be controlled by one platform, and that's one of the goals of the project. So we will use the facility that we have in Kezo, in Research Center. We will use the heat pumps, we will use absorption chillers, new heat pumps developed with partners, and new heat storage developed with other partners from other countries. And all will be implemented in our system. In our case, also the last project that I will talk about is a HiStor project. That's a project combining different electricity storage technologies to show the pros and cons of these technologies and how they could be mixed. The electricity storage based on lithium-ion, for example, and based on flow batteries, how to combine them together to have a perfect battery for specific needs of the consumer. So we are developing these systems and the smart control algorithms, how to build these batteries safe and how to manage them safely. So we have built for the purpose a local microgrid in our case. So we are developing the systems, testing them now, and at the end of the project is this year. So all of the projects are somehow connected that I told you about. Some of them are really specific about the specific technologies, but all of them are in a field of energy transition, of the smart energy system implementation in a real life situation in some rural and urban areas. So we are cooperating with companies on the field where the technology is already there, but need to be implemented somehow, need to be validated in the more relevant environment. So that's why we are filling the gap of this value of debt, as this is said. So we are working on that in that area with our partners to fill the gap. So we have good partners already now. We have good plans for the future, and of course that's why we are also inviting you for this type of cooperation. For now, it's going really well. We have great partners, we have great projects, and we are trying to really implement the technologies in the real life. So thank you very much, and if you need any contacts, here I am, and thank you very much.
Thank you, Mr. Bikoch. The next presenter is Dr. Maroš Halama, Associate Professor of Technical University Košice of Slovakia. The topic of his presentation is how Enigma problem inside batteries linked with monitoring and prediction of the health of electrodes in batteries.
Thank you for introduction. So I share screen. Okay, so dear Excellencies, dear distinguished guests, it is pleasure for me to introduce a topic on what's going on research on batteries and other supporting activities in clean tech sector in Slovakia from the policy perspective also. I would like to talk more about our research program, and we are dealing with Enigma problem inside batteries and how this problem is linked with monitoring and prediction of state of health of materials used in inside a battery. So it's international team consisting of our Technical University Faculty of Materials, Metallurgy and Recycling, Promatech Center, I will talk more later, and Instituto Superior Técnico in Portugal and Lisbon, and Slovak Academy of Science. I'm coming from Košice. Košice is well known as the Košice Applied Science City. Maybe some information behind the scene. Košice has always peace marathon in Europe, was European City of Sport and championship. But what is more important with our university is going back to the 17th centuries, where to Maria Theresia time when was University Akasovia Sciences founded. We have University Science Park Technicum, which is a good opportunity for students and staff and business sector to work on new ideas and commercialize this to the industry. We have here 3 Institute of Academy of Science which cooperating so much with universities and is in close proximity, so it's big advantages. We have some industrial partners. We have strategic companies located from IT sector, but also from steel industry, and now from battery sector also coming to Slovakia. And we have this Promatech Center. Promatech Center is a national research center for advanced materials and technologies. It's a really new infrastructure. It's going back to 2014 when it started, and has 39 labs with infrastructure of 20 million investments in Europe, only for devices for characterization of material. So we have like focus on beam microscopy here, nanospider, and some triple techniques, corrosion devices, and devices for surface treatment and for characterization. If I go back to a topic regarding the batteries, we know that in Europe there is a battery 2030 initiative, and it consists of a whole value chain going from raw materials through materials advanced materials in battery, when cell design, cell production, application like secondary life of batteries, and when recycling and reuse. I'm coming from Faculty of Materials, Metallurgy and Recycling, so we are closing full loops. We have a research group working on development of new materials, the advanced materials, but also with recycling technologies, but with industrial partners and with international partners. We also do some smart sensing and measuring and monitoring these physical-chemical parameters inside batteries, what's going on. The main focus is really interdisciplinary. We are dealing with covering material science, chemistry, also theoretical physics, but we apply also artificial neural networks and Internet of Things, and so really digitalize this material science sector. The main objective is the observation of degradation mechanisms of electrodes, so materials used inside the batteries. We use local impedance spectroscopy techniques, focus ion beam microscopy, ADX mapping analysis, X-ray analysis, X-ray mapping, and so on. From the value for money perspective, we have a partner from Poland dealing with theoretical physics and quantum chemical calculation, because we do some simulation and calculation in advance to experiments. So it is very fruitful information when it saves you money before doing high-cost experiments. And we have a great experience from nanotechnology sector already now. When we are dealing with surface treatment as prevention against degradation, so also nanotechnologies, because of Promatech Center, we cooperate so much. And as was mentioned in the previous Hungarian presentation, we also dealing with inoperando electrochemical parameters monitoring during the lifetime of batteries. So this is the main action here. We are also developing the prediction sensors. So we with measuring or monitoring this new physical chemical properties, which are not measuring right now in the commercial sector. We need to develop advanced battery management system which has predictive behavior. So what's going on interaction of these electrodes with environment, and to predict the degradation. From the recycling technologies, we use like standard techniques like hydrometallurgy, or also pyrometallurgical project are now running, but also in some innovative way of recycling technologies using acidic bioleaching or using bacteria for extracting metals from used materials. And also thermodynamic study here is very important, because it's hypnate with traditional experimental technique. So coming back to point, the enigma problem inside the batteries is degradation or corrosion of materials. You see here a lot of mechanisms taking place. We usually focus on interaction of highly conductive, highly aggressive electrolyte with surface of metallic materials, but also this separator which also somehow degraded, and when this is critical because you have a leakage in this, and this high aggressive electrolyte is in contact with metallic materials which can easily degrade. So we started this topic a few years ago with non-stable source of electricity on a power bank connected with photovoltaics. And as you see, after 200 cycles was aluminum foil totally degraded inside the power bank. So we go through analysis, macroscopic and microscopic. And as you see from scanning electron microscopy, and EDX analysis, we detect also chemical composition of this and trying to find mechanisms. We do also microscopic observation inside Li-ion batteries after cycling. So usually it's from laboratory cycling or from in field from e-cars after some thousands of kilometers, when the capacity is going slowly down, not critical, but only slowly down, and we try to catch what is the phenomena responsible for degradation. So not only anode, but also we observe also cathodic materials, anodic materials. You see here some results. For example, on anode, we detect higher oxygen content, which increase, of course, resistance or impedance on these surfaces, and when degradation concentrate in one place. Some other mechanisms like silicon was responsible for facilitation of degradation on carbon silicon anode coating on copper collector. And there is also critical role of phosphorus in degradation mechanism, because it's coming from aggressive electrolyte. When on cathodic material, after many cycles, you see also chemical analysis And here the main degradation is cementation of copper from collector on the cathode, where aluminum foil serves as a substrate, so which leads to the bimetallic corrosion, which is a really fast degradation site. So we need to protect somehow. We do also this development of advanced battery management system. So we monitor impedance, as you know, not only from potential current. It is possible to predict something because it's very late information and when the degradation is taking place, but we need to predict if degradation taking place in a very small extent and when to measure very precisely in some frequencies the impedance what's going on the surface electrolyte layer. So here are some results from these batteries inside e-cars used for 4,000 kilometers, I think, and 900 cycles from lab. What we use with international partners is local impedance measurement. So we are focusing also what is going on a micro scale. So you see impedance measurement on a micrometer level. So we detect, we choose the area like 2 millimeters, and we go like scanning through micrometers range where is the critical impedance is and what is the chemical composition. So we need to extract information on this.
Dr. Halama?
Yes, I will go through.
Sorry to interrupt you, but due to the limited time, would you please wrap up your presentation?
Yes.
Thank you very much.
We have a concept also to using artificial neural network. Now it's a case study from atmospheric corrosion. You see the prototype, so it's online version where you can measure variable impact analysis of your environmental parameters on Earth. So it's easily applicable for also battery sector. And maybe I go through the science policy and our activities, what we have done. So we are working on strategic research agenda for batteries at Batteries Europe, which is a platform to make strategic research decision across European Commission. We are a member of advisory board at some project like Spartacus with Fraunhofer Institute, and also we are part of McKinsey company study deployment of battery electric vehicles versus fuel cell electric vehicles, so hydrogen and versus battery vehicles with partners like Volvo, Toyota, BP, ETH Zurich, and so on. So some innovation activities, we are part of IPCI projects, so projects of European common interest. As you know, Slovak company was successful in 4 IPCI projects, and we are indirect partners in this. But it must gone with innovation education system in green tech. So we are part of Ulyseus with joint master and PhD degree across European network of universities with Sevilla, Innsbruck, and Helsinki. And we have some new laboratories here, as you see, and some innovative green tech mobile labs. So here you can see both technologies, also hydrogen technology and battery technologies in mobile container, which move through the region, and we teach the public and secondary grammar students. So this is some dissemination from Expo Dubai. We have launched also an adopted hydrogen strategy for Košice region. And I invite you for a conference, which will be in November in Slovakia, and will be under auspices of Vice President Šefčovič and Slovak Battery Alliance. So this is from my side. Thank you.
Thank you very much. The next presenter is Dr. Seung-min Hyun, Principal Researcher of Korea Institute of Machinery and Materials. The topic of his presentation is flexible and stretchable energy storage devices.
Thank you for a nice introduction. Hi, so good morning and in Europe and good afternoon here. So my name is Seung-min Hyun from Korea Institute of Machinery and Materials. Yes, slide is here. Yeah, I'd like to introduce one of my research areas. 저 포인터가 이게 레이저 포인터 안 나와요? 레이저 포인터 I'm looking for a laser pointer here, but it's not working. So I just briefly introduce my research area, flexible and stretchable energy storage devices. We have developed two types of energy storage device so far, supercapacitor and lithium-ion battery. And supercapacitor, as you know, is composed of two electrodes faced to each other. It's like a sandwich structure. So there are electrolyte and separator between two electrodes. Electrodes usually made of carbon materials. Once we apply the voltage at the end of electrode, ion arranged on the surface of electrode. So it's a kind of a surface reaction mechanism. So we can charge up supercapacitor very easily, and we can get a very high energy at instant second. But battery is similar, but a little different. There are anode and cathode. Anode is made of carbon materials. Cathode usually made of lithium metal oxide. There are electrolyte and separator between two electrodes. Once we apply the voltage between two electrodes, lithium ion transfer from cathode to anode. This is a charging mechanism. So once we put out this lithium ion from anode to cathode, we can obtain electricity. So we can charge up as a chemical energy, and we can put out as a electrical energy. So lithium-ion battery, the whole volume of active material, anode and cathode involved in this reaction. So energy capacity is much higher compared with the supercapacitor. That's a big difference. But it takes a little while to charge up the lithium-ion battery. And this is the outline of my talk. I briefly introduce application of flexible and stretchable energy storage device, wearable electronics. And this second part is briefly introduce my research result of stretchable supercapacitor and Mulberry paper-based supercapacitor and stretchable lithium-ion battery. And this is the energy storage device research trend. The most important thing is people try to improve the energy density and power density so far, and they will try to improve these two properties. The energy density is it's kind of energy term within an hour, so it indicated how much energy we can use 1 hour. The power density is instant energy release per second. So a little different term, but people try to make this high power density and high energy density device with stable operation. These are three key points. But at 7 or 8 years ago, I was thinking about might be another aspect of energy storage devices. If we make some more function on this energy storage device, we can use for wearable applications. Like if we make a flexible and stretchable energy storage devices. The history of a wearable device, something like this, before 90, the all electronic products is huge. It's huge. At that time, it's the most popular wearable device, Sony Walkman. I think people age more 50 years old realize that kind of products. But at 2007, Apple released the iPhone, so it's kind of starting point of release a lot of wearable devices. I believe in near future we can make a wearable device made of textile base. And this is a wearable electronics, so flexible to stretchable. So even 5 years ago, people asked me, why do we need a flexible electronics? All electronics use a rigid substrate. We do not need that kind of electronics at all. But due to Samsung produced a foldable smartphone, so people admit that kind of application, flexible electronics. If we have some kind of function, we can make a new type of product. Stretchable electronics, something like this. Even 2 years ago, people asked me, why do we need stretchable electronics? But look at this textile and patchable device. It's all required stretchability to make a reliable product. If we have this kind of function, we can design the new types of products in near future. And look at this slide bottom. So LED and semiconductor and sensor is a very tiny product. We can put this small product at flexible, stretchable, textile substrate. But however, energy storage device is a different story. It requires a high volume, huge volume. So we have to make a new types of flexible and stretchable energy storage devices. And so we have to choose the 5 types of substrate to make a flexible and stretchable energy storage device. The advantage of 5 types, something like this. The inside of this 5 types substrate, a lot of fiber, small tiny fiber entangled each other. If we control the amount of this fiber, we can control the flexibility and stretchability. Also, it has a high surface area, so we can increase the energy capacity. Also, one good point of these 5 types materials, the adhesion between carbon material is extremely good. So we can make a reliable product easily compared with another substrate. And this is our result of making flexible and stretchable textile-based supercapacitor. I briefly passed out this result. First, we have used 2 types of textile substrate, polyester and cotton, and deposit carbon nanotube on it and to make a supercapacitor. But we pull out this electrode and realize there is some interesting point. We actually accidentally reduce the resistance. Usually we deform the electrode, we have a high resistance electrode. But in that case, we have a increase conductance. So we have that kind of behavior, I believe. Before strain, a lot of fiber entangle each other, but CNT, they do not contact each other enough. But once we apply the mechanical strain, so CNT contact each other, so improve the conductance of our electrode. So if we make 2 types of supercapacitor made of this without strained electrode and with strained electrode, we have 2 different quality of supercapacitor. We improve the energy density and power density. So this is a stretchable supercapacitor. It's made of cotton substrate and coating the carbon nanotube, and mangan oxide coated on the surface of carbon nanotube. As a capping layer, we introduce a conducting polymer on the top of mangan oxide that improves the reliability of our supercapacitor. We can bend, we can stretch out this supercapacitor. At that time, we have used the solid electrolyte, like a polymer electrolyte, instead of liquid electrolyte. And this is a stretchability test. The top figure shows our supercapacitor light up the LED. But once we pull out the 21%, still working without any problem. It's a very reliable supercapacitor. And so look at this color of a supercapacitor. It's kind of dark. It's not beauty. So at that time, we tried to make a transparent supercapacitor. But accidentally, we realized we can control the color of our supercapacitor by charging mechanism. So accidentally, we have developed the electrochromic supercapacitor, not only transparent supercapacitor. So this is the introduction of an electrochromic device. Tungsten oxide is kind of one material. It's very transparent, but once we control the electronic structures, it turns out colored case. So it's quite a reversible process. We can deposit the tungsten oxide and glass substrate. We can control this darkness by external power source. But at that time, we try to use the flexible substrate and operating the electronic device without external power source, because we are developing supercapacitor at the same time. This is our development, the electrochromic supercapacitor. The supercapacitor usually same structures, but once we control this charging mechanism, we can control the color of our supercapacitors. And this is our supercapacitor. It's banded, and the charging and discharging state. Look at the color. One is transparent, the other one is a colored state. And this is a photoresponsible colorization. But title is fancy, but really it's just we put the solar cell with our supercapacitor. Solar cell is sensitive to the light. We use this solar cell as a light sensor if we have a high intensity of light, the supercapacitor now start to charging it. So it changes the color. And another topic is the mulberry paper-based supercapacitor. Mulberry paper is a Korean traditional paper. We call it hanji. So hanji has a very good performance. Look at this. Hanji has a high mechanical and high chemical toughness. We made a supercapacitor based on hanji substrate. And this is a process. So hanji, we deposit the active carbon on the hanji substrate and deposit P dot on the surface of active carbon to make a supercapacitor. So, and we put this supercapacitor inside of a high acid substrate and high alkaline substrate. We put in the 48 hours and realize our supercapacitor operating without any problems. So we made a very top supercapacitor. And so also hanji has a very good quality. It observes the carbon mass compared with another commercial paper. So we can make a big area, large-scale supercapacitor without additional process. And the last topic is we have developed a lithium-ion battery, the biaxial stretchable lithium-ion battery for soft robot applications. And this is a research trend of a lithium-ion battery as a function, make a rigid, flexible, and foldable, stretchable. And a rigid case is kind of pouchy cell. So it's commercialized. However, flexible and foldable, stretchable battery is not commercialized at all. Especially it's a stretchable lithium-ion battery. It published as a good paper. However, it did not work in atmosphere at all. We cannot use this stretchable device at normal life because once we pull out the lithium-ion battery, the air comes inside our lithium-ion battery. It destroys all of these our structures. So we have to find another way to make a stretchable lithium-ion battery. This is a kind of packaging issue. Actually, I have tried to make a stretchable packaging for a long time, but I did not find the new materials. I failed to develop new types of materials, stretchable packaging materials. So we have another approaches. So look at this snake. The snake is covered of scale. The scale is moving, but scale itself do not deform at all. But muscle behind the scale control the movement of this scale. So we use this kind of design to make our battery. Battery itself does not deform at all. However, the interconnection between two batteries are deformed and observe the deformation energy. So you can make a flexible and stretchable lithium-ion battery with a high reliability. And this is the performance of our stretchable battery. And look at this. This is a pouch. We bend it and test it. Look at this. And this is our stretchable lithium-ion battery. So, 이게 없어가지고 좀 얘기를 하려고 했었는데. Compared with the pouch monocell lithium-ion battery, we have developed a very reliable lithium-ion battery case. And this is a stretchable battery for soft robotics application. Usually soft robot requires external power source. It requires some power source connected by wires. But if we use this kind of structured battery as a surface, we can use a structure of a soft robotics. So we have to make this kind of design to make a reliable lithium-ion batteries. So, thank you for your attention. This is the end of my talk. And this is our research group, so still active. And some students, they have a job in university in Seoul and some other Seoul areas. Thank you for your attention.
Thank you very much. This is the end of the first session. This is the end of the first session. Please raise your hands if you have any questions about the presentation. Okay, if you have no questions, we will have a 10-minute break and come back with the second session. Thank you very much.
Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Don't be scared of what's to come. It's all for you. For one last time, let's hold our own and make it right. You took the high
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas, because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever.
Mike? Attention please, we are about to start the second session, so please come inside and be seated. 곧 2부를 시작할 예정이오니 모두 착석하여 주시기 바랍니다. 네, 신호해 주세요. Your Excellencies, dear guests, ladies and gentlemen, welcome once again to a V4 Public Diplomacy event, Clean Energy, Flavors and Melodies. The second session will start with a keynote speech given by Mr. Nishant Bharatwaj, lead of the Green Energy and co-lead of the Green Investment Services Unit from Global Green Growth Institute. The topic of his speech is achieving regional energy security, carbon neutrality, commitments, technologies, and best practices. Mr. Bharatwaj, would you please share your knowledge?
Thank you. Good afternoon, delegates, speakers, and participants. Organizers, can you please confirm that you can see my slides and you can hear me loud and clear?
Yes, we can. Thank you.
All right. My name is Nishant Bharatwaj and I lead the energy practice at Global Green Growth Institute, or GGGI. Let me start by thanking the Embassy of Hungary for inviting me. It is my pleasure to participate in this forum, and thank you for having me. For the benefit of those who have not come across GGGI, GGGI is an intergovernmental organization headquartered in Seoul. GGGI has operations in about 50 countries with 43 member countries. GGGI engages with governments as trusted advisors for supporting green growth priorities, and we are embedded in one of the line ministries of member countries. Our support to the government includes evidence-based policy support, developing bankable projects, business models, mobilizing green finance, and institutional capacity building. To start my presentation, let me say that the COVID pandemic and the recent geopolitical situation had a major economic impacts in many countries. Countries are also appreciating the role of energy security as an integral part of national security more than ever before. Decarbonizing energy systems and future-proofing countries' energy security through clean energy transition and carbon neutrality seems like a credible way forward. Recognizing the threats of climate change, EU has set a goal to become carbon neutral by 2050, which means EU member states have to do some serious work ahead. This will require government policies and actions to be forward-looking. However, the path is even more challenging for Central European countries, such as Czech Republic, Slovakia, Poland, and Hungary, or the V4, which still have dependence on energy from fossil fuels. Hence, it is important for V4 to scale up interventions to meet national targets to realize EU's carbon neutrality by 2050. During this presentation, I will highlight current energy landscape of V4. I will also briefly mention the EU's and V4's decarbonization targets. The later part of the presentation, I will highlight some of the promising technologies, best practices, which may play a major role in achieving the targets in some of the V4 countries. I will briefly highlight the opportunities to achieve national targets. As you can see from the figure on the slide, V4 countries are heavily dependent on fossil fuels. While large amount of coal is produced by Poland and Czech Republic, V4 also imports significant amount of oil and gas from Russia and other countries. Except Poland, V4 has nuclear power facilities to meet a large portion of energy demand. Czech Republic is the electricity exporter, whereas Hungary is one of the electricity importers in the region. On the renewables, biomass is primarily the key resource and contributions are also coming from solar, wind, and hydro. This is a slide for decarbonization targets and achievements. The left side of the slide presents the EU's achievements corresponding to EU's climate and energy targets by 2020, whereas the right side of the slide highlights the targets for EU and B4 under the European Green Deal. EU had the decarbonization target of reducing greenhouse gas by 20% from 1990 levels, increasing renewable energy share to 20%, and improving energy efficiency by 20%. EU and B4 has done quite well to achieve these 2020 targets on emission reductions and renewable energy capacity addition, with some lag in the energy efficiency. The road to 2030, as committed under European Green Deal and carbon neutrality by 2050, is indeed a very ambitious target. A lot will depend on the EU's emission trading system and the sectors under its purview, such as power, energy-intensive industries, and civil aviation. This slide briefly captures the sectors with large emission contributions in each of the countries. For instance, in Poland, the electricity and transport sector are the top contributors towards GHG emissions, whereas building and transport sector are the key GHG contributors in Hungary. Industries, mainly heavy industries, waste and transport sector are the major GHG emitters in Czech Republic and Slovakia. This implies that the specific focused action towards industries have a large emission reduction potential. On the energy transition to renewable energy and energy efficiency, this slide highlights the focus sectors and the respective targets of Poland and Czech Republic to meet 2030 goals. For instance, Poland aims to achieve a renewable share of at least 23% by 2030 in its energy mix by primarily focusing on biomass, offshore wind, and biofuel resources. Poland also focusing on mobilizing investment on nuclear energy, energy storage, e-mobility, and hydrogen infrastructure development. Whereas Czech Republic has a target of 22% share of renewable energy by 2030 by primarily focusing on advanced biofuels with some solar and wind. Czech Republic also aims to double its solar power capacity, more than triple of the wind power, and build geothermal energy as well as the biomethanation production from organic waste. For Hungary and Slovakia, Hungary has a target of 21% share of renewables by 2030, focusing mainly on changes to the transport and the heating and cooling sector. Minimum renewable energy shares in various sectors is targeted, such as 20% in electricity, 30% in heating and cooling, and 14% in transport. Whereas Slovakia aims 19.2% renewable energy share in the energy mix by 2030, with onshore, wind, solar photovoltaics, and bioenergy as the main focus area. Hungary and Poland are two V4 economies who would need substantial scaling up of actions to meet the 2030 targets. Let me talk about some of the best practices that are possible to meet some of these renewable energy targets. The first one is the floating solar projects. The need for continued expansion for renewable energy, limited availability of high cost of land has provided attraction for floating solar, where there is an availability of water reservoirs. Reduction in water vapors and improvement in the performance are the additional benefits of the floating solar. 1 megawatt of floating solar project has a potential to generate 2 million units of green electricity and avoids 2,000 tons of CO2 annually. GGGI is supporting the development of world's largest floating solar project with a capacity of 600 megawatts on one of the dams in India. The bidding for the private sector participation in the project has indicated a price of electricity under $5 per unit. This makes it a viable solution for V4 countries too. Green hydrogen for transport and industry. Hydrogen as a fuel has a great potential in many sectors. However, it is important to produce green hydrogen from renewable sources. Hydrogen is classified based on feedstock and the process to reduce CO2 emissions. Conversion of fossil fuels such as coal, natural gas to hydrogen is gray hydrogen. Capturing it and storing CO2 makes the previous process as the blue hydrogen. However, the electrolysis of water using the renewable energy electricity, we classify such a hydrogen production as a green hydrogen. Solar, wind, geothermal are among the most promising renewable energy sources that can be used for green hydrogen production. Decreasing cost of renewable energy, flexibility of storage, and the ambitious target to decarbonize hard-to-abate sectors are the key drivers for green hydrogen production. When we look at the economics of green hydrogen, there are mainly two technologies that are available. One is the PEM, the polymer electrolyte membrane technology, and the other one is alkaline electrolyzer technology. While the PM is an expensive technology as compared to alkaline, the efficiency of PEM is also higher. As per the current market scenario, the green hydrogen costs 3 times of that of gray hydrogen, which makes it very unattractive for use. There is also an opportunity to reduce the price differential through innovative mechanisms such as bundling green hydrogen with gray hydrogen at a premium cost, further reducing the renewable energy prices and reducing the capex cost through technology disruptions and economies of scale. Biofuels, there is a large, just to mention that GGGI is doing a green hydrogen project in 4 countries, India, Indonesia, Nepal, and Morocco. We have a large focus on doing a demonstration projects in the green hydrogen space and looking for opportunities to reduce the cost for green hydrogen and the potential to export in some of the economies looking to work on green hydrogen. Biofuels, a large fraction of renewable energy in V4 countries currently comes from biomass. Given the large availability and potential of bioenergy in these countries, have planned for renewable energy strategies around biomass, especially for the transport sector and the building sector for heating applications. The availability of biomass resource could address both energy security and carbon neutrality. Biofertilizer production and its contribution to sustainable agriculture are the core benefits of biomass. Bio-CNG is one of the very promising fuel, producing bio-CNG using biomass as an agriculture residue, organic industrial waste, biodegradable municipal waste, livestock waste, and the wastewater sludge are among the other uses, other waste that could be used for anaerobic digestion process to produce bio-CNG. The process and supply chain of a typical biomass bio-CNG projects is presented in the slide, as you can see. The conversion process generally involves 5 steps: biomass collection, pre-processing, storage, digestion in a digester, purification, and upgradation for the distribution. City and local gas networks can be used to evacuate the bio-CNG produced by these plants. GGGI has a global program on bio-CNG, which is running in many countries, including in India, Indonesia, Thailand, and Laos. We have realized that the cost of producing bio-CNG from organic waste can actually be lower than the CNG or the fossil fuel-based gases. In conclusion, decarbonization of emission-intensive sectors, which are covered under the EU ETS, is key to achieve EU's and V4 associated targets. Scaling up deployment of low carbon and carbon neutral technologies and adoption of best practices will help in achieving national and regional security and carbon neutrality. Financing the low carbon and the carbon neutral technologies and the infrastructure development at a scale needs mobilization of large investments. Cohesion funds, modernization funds are among, and others are some of the EU's funding available for various targets sectors such as renewable energy, e-mobility, energy efficiency. Further investment mobilization through green bond is another option. In 2020, Hungary successfully issued two first sovereign green bonds amounting to 1.7 billion euros. Carbon pricing promoted through ETS is an effective way to reduce greenhouse gas emissions. Revenues from carbon pricing could be used for finance investment gaps, compensate vulnerable households, and offset the taxes such as labor and other special cases. I wish all the experts a very successful discussion and deliberation. I hope this deliberation will provide inputs to the stakeholders and policymakers in V4 countries to develop regional and national level strategies to meet climate goals. Hungary is a member country to GGGI, and GGGI also has an office in Budapest. For any additional information, please reach out to us. Thank you.
Thank you very much, Mr. Bartois. The first presenter of this session is Dr. Silvia Zita Todt, Senior Research Associate and Group Leader of Biological Research Center of Hungary. The topic of her presentation is biohydrogen production by green algae.
Thank you very much. I start sharing my screen. Could you please tell me if everything's all right?
Yeah, we can see you. You can start. Thank you.
Okay, thank you very much. I come from Szeged, which is located here in the southern part of Hungary, and this is our research center. So, as you all know, hydrogen is used for various processes, such as processing fossil fuels for producing fertilizers. It is also widely used in the food and cosmetics industry and in engineering. And of course, it can be also used as a fuel. Currently, as you heard earlier, there is a big problem that hydrogen is currently mostly produced by reforming natural gas. And this results in a large release of CO2 into the atmosphere. And then there are several alternatives being developed to produce hydrogen in a renewable manner. There are both physical, chemical, and biological alternatives being developed. So we work on photosynthesis, and we try to use this phenomenon to produce hydrogen. So you may know that during photosynthesis, plants and algae use the energy of sunlight, carbon dioxide, and water to produce sugar and oxygen. And this process, photosynthesis, is the source of oxygen in the atmosphere. In the lower part, you can see an algal cell. It's called Chlamydomonas, and this is our mostly used model organism. So this is the photosynthetic electron transport chain. This takes place in the chloroplast. So the idea is that we have energy reaching the photosynthetic complexes, and then this so-called water or oxygen evolving complex splits water into oxygen and protons. And then there is electron transport, which will be used finally for carbon fixation. But in Chlamydomonas, or in green algae in general, there's also a hydrogenase enzyme located here, which is very efficient. Probably this is the most efficient enzyme that is capable of producing hydrogen found in nature. And this process takes place in nature, mostly when the cells, the algal cells, are under hypoxic conditions. And when we have photosynthesis starting, then first there is a few minutes when the electrons are used for producing hydrogen, and when the Calvin-Benson cycle, so the CO2 fixation starts operating, then this process is stopped. One main reason is that oxygen is produced, and that inhibits the hydrogenase enzyme. So for these reasons, hydrogen production lasts only for a few minutes in nature, and the aim of several scientists is to prolong this process and to make it sustainable. So in our approach, there are two key questions that we would like to solve. First is to keep the CO2 fixation inactive because it's a competing process. And the other issue is to remove the level of oxygen because that would inhibit the hydrogenase enzyme. So these two are the key factors that we have to deal with. So having this in mind, we have developed a very simple experimental system with the idea that it should be later upscalable. So first we just simply grow the algae in the lab in so-called Erlenmeyer flasks. Then we put them in closed serum bottles, and then we put them in the dark for 4 hours, because under these conditions, so we remove also oxygen and carbon dioxide, hydrogenase enzymes are formed. So after these 4 hours, we just simply put them in the light, and then the algal culture starts producing hydrogen. And then this may take several days. Mostly we use a 4-day experiment. So during these 4 days, we sample the gas phase just to measure the amount of produced gases, and also we remove the hydrogen and oxygen by nitrogen flushing every day. And this procedure is protected with a European patent. So these are our experimental results. So first we see that already during the first day, we have a substantial amount of hydrogen produced. And then if we remove the oxygen using a simple oxygen absorbent, then the amount of hydrogen is doubled. And then we can see that the amount of oxygen is much smaller in the headspace. So we checked how the photosynthetic apparatus behaves under these conditions. So we can say that the photosynthetic activity is sustained during the 4-day of hydrogen production process. And then we also measure the in vitro activity of the hydrogenase. We can see that there is a substantial decrease, but in the presence of the oxygen absorbent, this activity is fairly well sustained. And then we, of course, wanted to further improve the efficiency of this system. So that's why first we changed the geometry of our photobioreactor. So we used the thin layer cultures because that would help the gases to get out of the culture, of the liquid phase. And on the other hand, we also increased with this system the size of the illuminated area. And then we conducted the experiments at 2 cell densities, medium and very high cell densities, and also the intensity of sunlight. This is very important because in earlier algal hydrogen production systems, it was impossible to use the intensity of sunlight because the culture simply died. So it was a very important challenge that we wanted to face. So again, this is just a brief a small scheme of the system. So we have the oxygen absorbent here, we have the thin layer culture here, and then we have a very strong light. And the hydrogen will be collected in the headspace of the culture. So here you can see, so this is the summarizing figure, so that by changing the geometry of the photobioreactor and also by increasing the cell density, so simply we put much more cells in the same volume, we could increase the amount of hydrogen produced by a factor of 5. So, and then we wanted to check whether there are specific photosynthetic mutants that are particularly suited to these conditions. So I don't want to go into details, but we have tested many of them, and we found this mutant so-called PGR5 that could produce twice as much, actually 2.5-fold more hydrogen than the white egg. This is what you can see here. And now we produce about 1.2 milliliter hydrogen per milliliter culture in 6 days. Very importantly, under these conditions, this PGF5 mutant didn't get degraded at all, so it could maintain its photosynthetic apparatus. And very importantly, also its hydrogenase activity was completely sustained, completely maintained during the 6 days of hydrogen production under these extreme light conditions. This was a very important result that we could publish last year. So briefly to summarize, so in our approach, hydrogen production starts immediately upon elimination, and hydrogen is produced directly from water, and there are no organic carbon sources required. With this system, hydrogen production became possible at the intensity of sunlight. It lasts for several days, and we have quite a good hydrogen productivity. So as I said, 1.2 milliliter hydrogen per milliliter culture is produced in our PGF5 mutant. And after that, after the 6 days of hydrogen producing period, the cultures could be regenerated, or alternatively, they could be used in downstream processes. Like, for example, their biomass could be used as a biofertilizers, or even high-value compounds could be extracted from the waste biomass. So with this, we think that we could open new vistas towards bioindustrial hydrogen production. And our current aim is to upscale it. So first to greenhouse conditions, and if we are successful, then to outdoor conditions. So these are the main participants. So this is my research groups and the main participants. And we have also several collaborators from Denmark, and Israel, and Finland. So thank you very much for your attention.
Thank you, Dr. Toth. The next presenter is Ms. Teresa Stashakova, Ministerial Assistant Principal of the Ministry of Industry and Trade of Czech Republic. The topic of her presentation is development of green energy in the Czech Republic, the new path.
Thank you. Hello, thank you. I hope you can
Ms.
hear me well.
Ms.
Yes?
Stashakova, we cannot see you.
Oh, yeah. Now?
Yes, we can see you now. Thank you.
Better. Perfect. Thank you. Dear ladies and gentlemen, excellencies, good afternoon to Seoul and good morning to Europe. Thank you for giving me the floor. And first of all, I would like to thank the Hungarian presidency of V4 and the Korean delegation for organization of this absorbing event. And now let me begin my presentation. So, short outline. First, I will briefly mention the context of the European climate and energy policy and the main trends in energy, as both are defining for us. And then I'm going to talk about the Czech approach to the transition and about Czech green projects. However, the presentation should speak for itself. So where we stand today. Climate change and environmental degradation are crucial topics which are central to many discussions and which are framing our perspective on development, transformation, and also on our investments. The EU is active in several levels, and especially through the European climate and energy policy, which has become more and more important over past years. And one of the latest is an overarching set of policy initiatives, the European Green Deal, which aims on climate neutrality in 2050. However, as stated in the REPowerEU plan, which was presented last week by the European Commission, the situation has changed due to the Russian aggression in Ukraine, and this whole situation is accelerating the whole effort to energy transition due to the emphasis on energy security, decreasing dependency on Russian fossil fuels. So how to respond to this? One of the solutions is, of course, green energy and emphasis on sustainability and self-sufficiency. And here we can see 5 main trends which are shaping the discussion also in the Czech Republic. It is decarbonization and focus on low carbon sources and energy efficiency. It is decentralization and again focus on decentralized sources and resilience of the infrastructure and energy storages. It is digitalization and focus on smart grid, Internet of Things, 3D printing, etc. Also, what is important is democratization and focus on new actors, energy communities, aggregators, but also on smart metering, smart cities, and positive energy districts. And the last trend is sector coupling, power to X technologies, which were already mentioned, and of course, electrification and use of hydrogen for energy storage, etc. However, every country has specific possibilities which has to be taken into account when we talk about energy transition. And the Czech Republic, as an industrial country, and therefore we have quite high energy intensity. We also have a long fossil fuel history, and historically there was an emphasis on big centralized sources as coal and nuclear power plants. And both those factors are creating a certain path dependency for us. Also, in context of renewable sources of energy, I have to know that the Czech Republic is located in mild climate conditions without access to sea. And therefore, we don't have such a solar potential as, for example, certain countries, nor possibilities for offshore wind. And this whole context is quite significant for us when we think and talk about energy transition, about energy policies, etc. However, the need for decarbonization is a priority for us. And one of the ways to focus on is support for decentralization and support for green energy. So within this sector of the energy transition, we see two main challenges. First, it is for us the transformation of coal regions, which has a socioeconomic impact. Second is mild climate condition, which does not create the best condition for renewables, as I already mentioned, but it doesn't mean that we cannot have them. We can still deploy them. However, there are other opportunities we can build on. And this is, from our perspective, robust and resilient energy systems and development in smart grids, which allows us a better deployment of decentralized sources. And what is also important is that there is a crossbench support of the government for carbon neutral energy mix based on nuclear renewables, and also we are discussing hydrogen now. And therefore we can focus on one strategy, and this political unity is quite important from this perspective. And also there is a broad support of renewables and green energy through investments, subsidies, and also easier administration of all those processes. And we also have two national plans supporting green energy. One is the National Action Plan for Smart Grids. The other one is National Energy and Climate Plan. Here, this slide shows basically investments in the field of energy. As you can see, they are increasing, and especially in the field of renewables, energy efficiency, hydrogen, and nuclear. Energy efficiency is this blue, renewables, this gray, nuclear, this yellow. And green is solutions or other power and storage technologies, and blue is hydrogen, of course. So moving on, this slide shows green energy production in the Czech Republic. On the left, you can see the share of energy from renewable sources in different sectors, and also the ambition goal of REPowerEU in 2030, which is 45%. And this goal is now or currently being discussed on the EU level. And this goal is considered from our perspective as quite challenging considering our climate conditions. On the right, you can see that the main renewable sources or renewable source is still biomass, then solar, hydro, and wind. And we also have some geothermal projects, but they are still in development. And finally, the green project. As I do not have much time to go into detail, but I wanted to give you a good overlook, I would just briefly mention 3 small local solutions, which is the city of Kniežice, which is very interesting, energy self-sufficiency city. Then the city of Rapotín, where is the first biomethane production plant in the Czech Republic. There are more, but this is quite a big one, an important one. And then the city of Česká Lípa, where is a new project where a research company, Membrane, has developed a technology that can process and use biogas from wastewater treatment plant or a biogas plant as a fuel, therefore as a bio-CNG. Where we excel is the field of smart grids, where our TSO and DSOs are very active. I would mention here the Prague distributor, and for example, their smart street lighting. I will show a picture on the next slide, and also interesting projects of EGD, which is the southern distributor, and they have 2 interesting cross-border smart grid projects, Icon and Cabretta. And for more details, you can have a look at the link here in the presentation later on. And just to mention a few more, I would mention agrivoltaic systems and the research around it, which is exploring synergies between photovoltaic installations and agriculture. Or I would mention geothermal research, which is very promising, and there is nice research center, and we are looking forward for the results. It's called Ringen, and again, you can have a look at the link in the presentation later on. And here are just some pictures. Here on the left, you can see the smart lighting on the street. It includes solar panel and charging for electric cars. In the middle, there is photovoltaic installed in the middle of the field. And on the right, there are some pictures from this geothermal research. So this would be it from my side. Thank you for your attention. And if you have any questions, you can reach me on my email address.
Thank you, Ms. Stashakova. The next presenter is Mr. Piotr Kropinski, Head of Hydrogen Economy and Innovation Unit of the Ministry of Climate and Environment of Poland. The topic of his presentation is Polish government support for R&D in the field of hydrogen technologies.
Hello. Just wanted to make sure if I'm visible and you can hear me.
Yes, we can hear you.
Okay, and just
So would you please share your knowledge with us?
yes, I'm very glad I can share with you. I have the opportunity to share with you information about the Polish system of support in the field of hydrogen technologies. And unfortunately, due to urgent plans, Director Beliński couldn't attend the meeting, but I'm the head of Hydrogen Economy and Innovation Unit at Electromobility and Hydrogen Economy Department, Ministry of Climate and Environment. And I'm currently focusing on drafting a stable regulatory environment for hydrogen market. So we can start with the presentation. Just a moment. Okay, I think it's a full-size screen now, so you can see this clearly. And first of all, I'd like to share with you a few words about the context of the Polish market. So Poland is the third producer of hydrogen in Europe, according to data from 2020. It may change, of course, because every country aim at producing more and more green hydrogen. But we have an ambitious to keep that position and to become a relatively big player on the hydrogen market. As you know, the European Commission on the 8th of July published a hydrogen strategy of climate neutral Europe. So, and its main objective is to stimulate the development of green hydrogen sector to achieve zero carbon economy. And following that, the Polish Council of Ministers adopted Polish hydrogen strategy until 2030 with an outlook until 2040. And it's a strategic document that sets the main objective of development of hydrogen economy in Poland. So the ultimate goal of the strategy is to create Polish branch of hydrogen economy and its development in order to achieve climate neutrality and maintain competitiveness of Polish economy. Also, we are, I think, the first country that prepared a hydrogen sector deal. And it means that representatives of government, administration, business community, science, and business units signed a sectoral agreement. I will tell you more about this agreement later, but all the participants agreed to support the growth of the hydrogen market in Poland with the local content. Also, we have two main institutions supporting research and development in the field of hydrogen technologies. The first one is National Center for Research and Development. It's supervised by Ministry of Science and Higher Education. And the second is National Fund for Environment Protection and Water Management. This fund is supervised by Ministry of Climate and Environment. On the European level, we have this IPCEI projects, important projects of common European interests. It's a part of state aid modernization, and it also provides schemes for supporting research and development in the hydrogen. Coming back to the Polish hydrogen strategy, we have 6 key objectives. The first one is the implementation of hydrogen technologies in energy and heating sector. The second, use of hydrogen as an alternative fuel in transport. A third, use of hydrogen as means of decarbonization industry. The fourth is hydrogen production in new installations. And fifth, efficient and secure hydrogen transmissions, distribution and storage. And the last one, creation of stable regulatory environment. Apart from the last one, all 5 key objectives may be supported by state aid. So in these documents, we agreed to support the low carbon hydrogen production, hydrogen distribution, alternative fuels, power to X technologies, energy and hydrogen storage, and combined heat and power production. And of course, we do not forget about the framework and environment to grow the market. So we will support the establishing of Polish hydrogen valleys. And also we are going to establish a new hydrogen technologies center, I think later this year, but about this technology center, I will tell you also a little later. Okay, so the hydrogen valleys. We have already actually 5 hydrogen valleys that are working currently now, and we of course support the establishing of this, but coming back to locations, we always look at some factors that are helping to promote and to establish this hydrogen valleys. The first one is industry location. Second, regions of gray hydrogen production today. Also, important factor is that it is close to the big cities in Poland. It's always important that we have close by renewable energy sources. Some of them must they take part in this IPCEI European projects, and also we look if this in this valley we have this academia and higher education units that will support research and development. So as you see on the map, we have already 5 hydrogen valleys. Each hydrogen valley may choose its own smart specialization, and we will soon prepare the system to coordinate the activities in hydrogen valleys. So we want to establish an operator that will work with currently established valleys to decide on which field they want to specialize. And also we are preparing governmental support for these entities. Okay, coming back to the framework, we are going to establish hydrogen technologies center. It's going to coordinate research and development projects. Also commercialization of the research and development activities, results of these developments, and it will coordinate delivering products for the hydrogen economy, providing consulting services and development works, initiating new activities, raising funds for research and development activity, and also it will handle the society education in the field of hydrogen technologies. It will be the part of the already established Institute of Power Engineering, and it's going to start this year. Okay, I already told you about the sector deal. It was concluded on the 14th of October 2021. The Polish hydrogen sector deal gathers public administration, entrepreneurs, academia, and environment and business. And the participants agreed to support 5 strategic objectives: local content, research and development, investments, people, and cooperation. In the research and development scope, it is fuel cells, power-to-X technologies, hydrogen purity, electrolyzers, low carbon and renewable and hydrogen production, hydrogen storage, distribution and transport, hydrogen blending with natural gas, and hydrogen refueling methods.
Mr. Kropinski? Sorry to interrupt you, but due to the limited time, please wrap up your presentation.
Okay, sorry, I will try to make it shorter. Okay, maybe one example of the program that is currently working. We have these new technologies in the field of energy. So you can see that we have an overall budget of 377 million zloty. It's about 80 million euro, and I think you may assume 1/3 of this is going to support hydrogen projects. And the time frame is by the end of 2029, and the scope of the support is electrolyzers based on renewables, hydrogen production from biomass, hydrogen production from methane pyrolysis, and fuel based on hydrogen. We have also a new energy program that is another example of the project that is currently working. Okay, and the last thing, it's the expertise that we need to establish a committee for research and development in the field of hydrogen technologies to choose the most promising projects to support. I think if we are running out of time, you may of course contact me and ask questions about the funding scams. Unfortunately, I couldn't tell you more about the European level of support, but we have 9 Polish projects that are of common European interest, and they are also pre-notified by the European Commission. I hope we will soon be able to provide state aid for this kind of projects. So thank you for this opportunity to share with you this information, and I hope I will leave some time for the next point of agenda. Thank you.
Thank you, Mr. Kropinski. The next presenter is Dr. Tomasz Brestovich, Professor and Vice Dean of Technical University Košice of Slovakia. The topic of his presentation is research in the field of hydrogen technologies. Mr. Brestovich?
Yes, please give me 5 seconds. It's everything okay? You can see the presentation?
Yes, we can. Thank you.
Okay, thank you. Good morning to Europe country and good afternoon to Seoul. Please let me introduce, ladies and gentlemen, my presentation, which is focused on hydrogen technology at Faculty of Mechanical Engineering. This is one of faculty on Technical University of Košice. I must thank Associated Professor Halama, which introduced Košice and Technical University. I can directly go to hydrogen technologies. Here we are focusing to hydrogen storage because we mean this is the very high problem with the hydrogen, and we are focused more than 15 years to hydrogen technologies. If we want storage huge amount of energy in hydrogen form, we must create very high pressure because hydrogen has very low density. In the car, it is 70 megapascal. In the bus, it's 35 megapascal. And energy consumption by this compression, it's about 20%. If we want to use liquid hydrogen gas, the energy consumption is about 30% because temperature of storage is minus 250 Celsius. We have the another possibilities to storage the hydrogen like chemical hydrides or hydrogen storage on the surface of activated carbon or metal organic frameworks. We focused on hydrogen storage in metal hydrides. 8 years ago, we created the first green hydrogen laboratory on Slovakia, which produce green hydrogen from photovoltaics panels, from solar energy, of course, and this energy go to the electrolyzer. This is alkaline high pressure electrolyzer, which have on the end of producing hydrogen with purity 99.95%, and pressure is about 2 megapascal. And for storage, we use the metal hydride storage tank, which can use very low pressure to absorbing hydrogen into intermetallic structure. Therefore, we don't use and don't need a compressor to compress, and we can directly storage this hydrogen to this tank. The electrolyzers which produce the hydrogen can produce 0.5 cubic meter per hour and contains this purification and dehydration unit. After this purification, go hydrogen to 3 metal hydrides tank, which total capacity is 27 cubic meter, and pressure of absorption it's about only 1 megapascal. If we compare this with the empty tanks, if we don't have the alloy, the pressure is 30 megapascal. It's extremely decreasing of pressure of hydrogen, and there is this system very safe, of course, safety first. These molecules of hydrogen is dividing with catalytic effects and are stored in this intermetallic structure. We cooperate with Slovak Academy of Science, and we are creating the new type of metal hydrides alloy based, its structure is crystalline, amorphous, or at the last time it's a high entropic alloy, which can absorb a huge amount of hydrogen into intermetallic structure. We can testing metal hydrides alloy in high range of pressure from vacuum to 6 megapascal and in the range of temperature from minus 200 to 500 Celsius. The utilization of metal hydrides is not only the storage of hydrogen, because this alloy has very interesting properties. It's very high pressure gradients if we change temperature. If we change temperature about 40 Celsius, for alloy lanthanum, cerium, and nickel, we can increase 4 times the pressure of hydrogen. Therefore, we produce the first metal hydride compressor in the Europe, which utilized to transport heat between two metal hydride tanks, MH2, MH1 and MH2. We utilize it for this transport of heat pump. And with this way, we can have very low energy consumption by compression. Here you can see the final construction of this fully autonomous control compressor for hydrogen. Is a very safe system, constructed modularly for very easy manipulation with the students, and this system can testing the new metal hydrides material for compression. The compression ratio is about 4. The next possibilities, the utilization of these metal hydrides alloy, it's hydrogen separation. We have a plasma reactor, and this plasma reactor can recover waste and produce synthesis gases. This gas contains very often hydrogen with concentration more than 50%, and after purification with PESA process, we can increase the purity directly with this metal hydride separator, because hydrogen is absorbed into intermetallic structure, and after removing the second components like carbon dioxide, we can increase the purity of the hydrogen. This is on this slide. You can see diploma work on our department, and this is the first model of hydrogen hybrid car with implemented metal hydrides alloy with the total power of 500 watts. Its dimensions and length of this model is 1.2 meter. Of course, if we want insert these metal hydrides to mobile application like bus, we must create metal hydride tanks. If this alloy absorb hydrogen, produce heat, and we must remove this heat from this powdered material. Of course, powdered material has a very low thermal conductivity, and therefore we must design container with very good internal and external heat exchanger. Here you can see our produced and certified metal hydride containers compatible with standard EN 12322, and these tanks can be used for stationary and mobile application. For demonstration, this utilization of mobile application, we create cooperation with Rochero company here in Slovakia, and insert these tanks to these low pressure tanks, of course, because these tanks have pressure about 1 megapascal. We insert these tanks to bus, which is designed for public transport. And you can see here the tanks, the implementation of fuel cell, and finalization of construction with cooperation with Rochero and Technical University of Košice. This is the first run and first testing ride of this bus here in Slovakia, and together with this bus, we create, with cooperation with another firm, Matador Group, the concept of car for Expo 2020 in Dubai. And here you can see visualization and a real application of this car in Expo 20. Excuse me, it's 2020 Dubai, of course. And here is the final construction of this low pressure bus, which contains 5 kilograms of hydrogen, because it's for public transport. The range is only 180 kilometers, and maximum power of engine is 150 kilowatts. And it's all from our research. Of course, if you have any question, please don't hesitate to contact me, and thank you for your attention.
Thank you, Dr. Brestovic. The next presenter is Dr. Sejin An, Principal Researcher of Korea Institute of Energy Research. The topic of his presentation is research activities on photovoltaic at Korea Institute of Energy Research for Carbon Neutralized Society.
Can you see the file?
We cannot see the file yet. Yes, we can now.
Okay. Thank you for a kind introduction. Good morning and good afternoon, ladies and gentlemen. My name is Sejin An from Korea Institute of Energy Research, and I'm happy to have a chance to introduce the research activities on PV at KIER for Carbon Neutralized Society. Let me first start with brief introduction of our institution. KIER has been established in 1977 with the aiming of contribution to creation of a national growth engine and economic development by energy R&D and its diffusion. Totally 60 regular members, including 37 researchers, are working together. And you can see here our research divisions. And actually, we are covering most of the energy sectors except the nuclear power. You can find here renewable energy institution and photovoltaics. Regarding the photovoltaics research departments at KIER, this department has been established in 1980 as the only professional PV research institution in Korea. Actually, because there was no interest at the time on PV, because it was only the expensive energy sources. And from 1990, we started research on conventional crystalline silicon PV. And soon we also start working on next generation thin film type PV technology, first in Korea. And till now, we believe that we are working as the research hub on PV in Korea. And now we are trying to our best for further technology transfer to industry and to read the future technology of PV. This shows the overall value chain of PV technology, and starting with polysilicon material, ingot, wafer, and then cell module, finally system. And actually, our department is covering the area from solar cell to the system part. Recent mega transition towards carbon neutralized society suggests that there are many different sectors which should work together to satisfy this goal. And PV is actually one of the major players in this scenario as the carbon-free electricity source. But to achieve this goal, conventional application of PV as a separated and centralized the PV photovoltaic power plant is not sufficient, because we need a huge amount of PV which should be newly installed to achieve the carbon neutralized society. So I think that PV should be everywhere we can see in the real world. So we should expand this application field from the conventional one to the more emerging field, such as building integrated PV, energy source for small electronics, vehicle or floating, and even agricultural application as well. Particularly, our department is paying great attention to the urban power distribution utilization. This is mainly because, the Korea is a small country with only limited space for PV installation. So in this, we can say this is simply a city application field of PV. So here, I can say there are two major technical issues, which is first, we need to increase the efficiency of solar cells much more than the conventional one. Again, due to the limited space. So in the limited space, we need to extract maximum amount of electricity. And secondly, to widen the application field of PV, we need more functionality compared to the conventional glass-based rigid PV module of crystalline silicon. So it includes flexible or lightweight, and even sometimes transparent technology. So according to this trend, I think I can say this is a summary of our overall research activities on solar cell here. Of course, we are actively working on the development of a high efficiency silicon-based solar cell, which is conventional one. So we are targeting to achieve the more than 25% efficiency in this technology with the size of conventional wafer size M10. And together with this, now we are actively working on merging this first generation conventional technology with emerging thin film type PV technology. And the first example is making the tandem PV, where two different solar cells are merged into one body. And the main goal of this technology is boosting the efficiency of solar cell even more than the theoretical limit of the conventional one. So we are now targeting 35 efficiency with this technology. And furthermore, as I told you before, to widen the application of field of PV, we are trying to develop the flexible, transparent PV. And even though this is not directly PV, but smart window application as well. If you look at a little more about the tandem solar cell technology, because we have our research priority on this subject. I already told you that the single junction conventional crystalline silicon PV has its theoretical limit, which has the number of around the 29%. We can explain the reason for that in this way. If we have this semiconductor light absorbing material with fixed band gap, when the energy of incoming light is less than this band gap, it cannot be absorbed by this material. So we optically lose it. But even when the energy of light is even higher than this band gap, unfortunately, this excess part of energy, we lose it as the unnecessary heat generation and material. So we have two loss mechanisms in that way. So we can say if the band gap of material is fixed, then theoretical limit is automatically established. And for the crystalline silicon conventional case, it's 29%. But due to the recent very nice improvement in this PV technology, currently the world best lab scale cell already achieved more than 26% efficiency in the real world. It means there is too small gap between the theoretical limit and current best efficiency. So further improvement in this technology in efficiency is actually difficult to expect. Then how can we go further beyond this number? That one solution of that issue is the tandem PV. How? So based on this explanation, the answer is if we merge or integrate the multiple solar cells with different band gap. For example, in this way, we have two different solar cells. And the first one, we say top cell, use the high energy portion of line more efficiently than before. And the bottom cell here can use lower energy photons more efficiently than before. So in this way, we can achieve much higher efficiency than single junction conventional crystalline silicon solar cell. And the theory says if we make a nice two junction device in this way, we can achieve more than 40%. And even though this is not practical one, if we can make good infinite junction, then you can achieve more than 60%. So now all the solar cell researchers in the world is now paying attention to this new technology. But of course, there is a high technical barrier, as we can expect. One of the barrier is the so-called current limitation in the bottom cells. Okay. If you look at the structure of tandem device in this way, we have two different solar cells, top, bottom. If you look at the bottom cells, okay, then due to this inherent structure, silicon bottom cell can only use a very small amount of light, which was already used by the perovskite top cell, and only some remaining portion can be utilized by this bottom cell. So in ordinary condition, the bottom cell current generation is always smaller than the top cell. And because these two cells are series connected in electrical circuit, when one part has lower current generation, then it will dominate all overall current generation in the overall cells. Means this low current will limit the efficiency of overall tandem cell. That is the reason why, even though we are merging two nicely working two solar cells, but its tandem efficiency is now always twice of each. Very difficult to achieve the double of it. So practically, scientists set the practical target of this technology at 30%. And I think, personally, I think at most 31, 32, that can be the maximum. But our institution have some different idea to resolve this issue. We think about the possibility that why don't you more actively use the rear side reflected light from the Earth's ground. And it is well known that Earth's ground always produce some reflect light, and this is the average value.
Dr. An, sorry to interrupt you, but since we have limited time, could you please wrap up your presentation? Thank you.
Okay. So we are approaching the different technology with actively opening the backside. We are now targeting more boosted efficiency of more than 35%. And this is our recent achievement on the perovskite cell and other PV technology. And we are welcoming any working partners from outside of Korea who can work together on this field actively. Thank you very much.
Thank you very much, Dr. An. This is the end of the second session. Does anybody have any questions about the presentation? If you have no questions, let's move on to the next program. The Visegrad 4 countries brought their famous alcoholic drinks here for you to have a taste. You will have a brief introduction about them first. Please welcome our colleagues who will introduce the drinks. First, Mr. Istvan Medviji from Hungary.
So I can take off my mask, right? Hello, everybody. I guess you had quite a few slides today, so we'll do the tasting presentations without any slides. Just explain you briefly what our countries are famous for as far as spirits and alcohol is concerned, and then you will have the chance to try those drinks. Hungary starts, so I think I can be quite confident to say that we are a wine nation. Modern day Hungary is quite a, as you may know, quite a tiny
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me and I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Don't be scared of what's to come. It's all for you. For one last time, let's hold our own and make it right.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me and I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Don't be scared of what's to come. It's all for you. For one last time, let's hold our own and make it right.
You took the high road. You've got to let it go. You see that I am wrong. You took the high road.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good idea, Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good idea, Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Don't be scared of what's to come. It's all for you. For one last time, let's hold our own and make it right.
You took the high road. You've got to let it go. You see that I am wrong. You took the high road.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your style? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me tight?
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas. Because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your smile? Is that your legs wrapped around me tight? Is that your smile? Is that your style? Is that your legs wrapped around me and I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. Is that your voice, so sweet of yours? Is that your hand I wanna hold so long? Is that your look? What's the hook? I can only say that this is so good. Is that your smile? Is that your style? Is that your legs wrapped around me tight? And I love you like no one ever loved loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. And I love you like no one ever loved anyone before. I know, yes I know.
Don't be scared of what's to come. It's all for you. For one last time, let's hold our own and make it right.
You took the high road. You've got to let it go. You see that I am wrong. You took the high road.
Far from the hustle and bustle of the city, explore a natural wilderness. Stunning landscapes, majestic forests, and pristine national parks. Endless sandy beaches and thousands of lakes. Come to cities rich in history. Hear about amazing legends. Discover the flavors of traditional cuisine. Experience a new adventure. Fall in love with the great outdoors. Poland, everything you want.
Beautiful and diverse, the very heart of Europe. Beautiful landscapes, multifaceted culture, unique folklore. Slovakia is no longer pursuing its beaten track. We are writing a different and modern story. A story about a forward-looking and inviting country that's able to attract talents and investments. Because it's ideas that are the biggest treasure in the modern world. If there is something we can be really proud of, it's the power of ideas. So let us introduce Slovakia to the outside world as a country where ideas are both born and turned into reality. Let us present a country of good ideas, because Slovakia is a good idea. Good idea, Slovakia. A simple, powerful idea being able to inspire the world as well as Slovaks themselves. Good Idea Slovakia is both the slogan and the brand of Slovakia at the same time. Multi-layered typography created by applying the typeface of the world-famous Slovak designer stands for the variety and richness of ideas. Good Idea Slovakia.
Your Excellencies, dear guests, ladies and gentlemen, welcome back to the V4 Public Diplomacy event, Clean Energy, Flavors, and Melodies. The artists from the V4 countries are now ready to show you their beautiful melodies. The first performance is a violin and piano duet of Bela Bartok's Romanian folk dances. Please welcome Mr. Wojtek Dziembowski and Ms. Arem Kim. Now, please enjoy the horn solo of Zunetek Phoebe's poem Opus 39, performed by Mr. Michal Evanovsky. Next, the piano solo of Eugen Sonyu's Adagio in G minor for piano will be played by Ms. Yunha Hwang. For our next performance, please give a warm welcome to Mr. Wojtek Dziępowski and Ms. Arym Kim. They will play Henry Wieniawski's Legend Opus 17. And it will be followed by the violin solo of Grażyna Baczewicz, Polish Caprice, performed by Mr. Wojtek Dziępowski. Now, please welcome Mr. Sung-eun Lee. He will sing Ferenc Liszt O Lieb, so lang leben kannst, with a piano accompaniment played by Ms. Arum Kim.
Und Sorge, dass dein Herz glüht hegt und Liebe trägt, solang ihm noch einander Herz in Liebe warm entgegenschlägt und wie dir seine Brust erschließt, o tu ihm, was du kannst, zu lieb, o tu ihm, was du kannst, und mach ihm jede Stunde froh, und mach ihm keine Stunde trüb. O mach ihm jede Stunde froh und keine trüb. Und hüte deine Zunge wohl, bald ist ein böses Wort gesagt. O Gott, es war nicht bös gemeint. Der andere aber, der andere geht und klagt. O lieb, solang du lieben kannst, solang du lieben kannst. O lieb, solang du lieben kannst. O lieb, solang du lieben kannst.
Now, Mr. Wojtek Dziembowski and Ms. Arem Kim will play Bedrzychy Smetanias from my homeland. Next is a piano duet of Ferenc Liszt Hungarian Rhapsody for one piano, four hands, performed by Ms. Yunha Hwang and Ms. Arum Kim. The finale of tonight's cultural program will be a Hungarian traditional folk music performed by Hungarikus. They play the heritage of the Hungarian musical tradition, the Hungarian folk dance music of the late 18th and 19th centuries, and the folk music sources of Hungarian composer Bartók, Kodály, and Liszt. Please welcome Hungarikus.
nagyobb sincs, kinek szíve bánatban nincs. Gyújtottam gyertyát a vőlegénynek, néztem szerelmét a mennyasszonynak. Jaj, pártám, pártám, gyöngyös koszorúm, majd szögre vetlek, ékes hajfonom. Hopp kint a pusztán, a padlódeszkán, nem leszek többé nyoszoljú leján. Ha leszek, mennyasszony leszek, annak is pedig legszebbje leszek. Ha leszek, mennyasszony leszek, annak is pedig legszebbje leszek. Mikor a mennyasszonyt fiktetni viszik, akkor a vőlegényt láncba kötözik. Sej párta, párta, gyöngyös koszorúm, majd a szögre vetlek, ékes hajfodom. S mikor a mennyasszonyt viszik a padlásra, neved a szoknyája a létre fokára. Sej párta, párta, gyöngyös koszorúm, majd a szögre vetlek, páros hajfodom. Sej pártám, pártám, gyöngyös koszorúm, majd a szögre vetlek, ékes hajfodom. folyamaton, ha nap felkél. Cseng szép madárszózat, vígan sétál sok vad, reggel, hogy elmúlt éjfél. Újul zöld bokor is, de nekem akkor is dolgom csak gondbús beszél. Hely, Rákóczi, Bercsényi, magyar vitézek, nemes vezéri. Hová lettek, hová mentek, válogatott vitézi. Hallgassátok meg, magyarim, amit beszélek, tanácsoljatok, vitézim, hogy mi tevő legyek. Jön a német, túlful éget, rabol mindent, jaj, vitézim, most már mit tegyek? Tanácsoljuk felségednek, meg se is vesse aranyait, ezüstjeit rutakba veresse. Rakassa el, vitesse el, hordassa el, és menjen el, merre szeme lát. Megcselekszem, elkövetem, mondja valaki, sőt, szeretem, meg se vetem, oktasson akárki. Ki az oka, minden látja, de tudja meg, hogy megbánja Spion Károlyit. Megfizeti még az árát az árulásnak, kipótolja maradékai eszet a másnak, hanem másnak, árulásnak. Úgy lészen még dolga néki, miképp Júdásnak.
Akkorra sem jött, tud meg soha sem jött. Madárkám, csináltatok neked gyémántból kalickát, ezüstből kadlócskát. Énes adok neked, zsemjecipót enned, zsemjecipót enned, muskotájbort innod. Nem szoktam kalickába lakni, kalickába lakni, padlócskán sétálni, muskotájbort inni, zsemjecipót enni. Csak szoktam ágról ágra szállni, ágról ágra szállni, fenyőmagút enni, fenyőmagút enni, gyöngyharmatot inni.
This is the end of program we prepared for tonight. Thank you very much for being with us, and see you again.